coffee stains and nimble chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really. I'm a and nimble chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
Yo, Chow. What's up? What's up? We back. I was working on my website earlier. We back. We back. Yes, sir. Lico Beast Mode. Yo, A, you ready? You ready for later? We gotta do more Amazon prep at all costs. Hell yeah. Alright, sounds good. Sounds good, boss. We have somebody coming up right now. Let me test. How's the audio sound, by the way? Audio's good. Bro, I need like a cold drink. Sounds good. Okay. Got the first person in. Hey, what's up? How you doing?
What's up? How's it going?
Nice to meet you, bro.
Nice meeting you too, buddy.
What are you up to? Let's see. Were you studying already? Or no?
Yes. I mean, so here's the background on me. I actually lucked out in 2022, right?
Yeah.
I never touched leak code seriously, but then Amazon, of course, being the only fag that would ever reach out to me, actually reached out to me this July for to recruit me. And finally, I started taking leak code serious. Actually, addicted to it now.
Addicted.
Not gonna lie. Yeah,
fun,
I
huh?
mean, it's fun, but I'm so trash at it. So I'm try to improve as much as I can. And I've watched you before. I was like, you know what? Let me embarrass myself live. So
Man, let's get it. I mean, this is
Yeah.
put your skills to the test right now.
no, the lack of skills, let's just say.
Okay, so you're already a software engineer too
Yep.
at a Fortune 500 company. You've solved 183 leak code questions already.
Yep.
Damn, that's pretty good. And you're taking the Georgia Tech online masters?
Yep. I
Perfect.
actually just started this past week. So
Is it hard? Or not really?
yeah, I mean it's just because so my specialization that I'm going into is computational perception and robotics,
Damn.
which has a
Fancy.
lot of artificial intelligence into it. So a lot of probability. I don't know why I chose this, but I hate probability, and that's literally the only thing that I'm studying right now.
Yeah.
So I'm actually hating life right now. So
I mean, you're trying to get into the AI stuff then, I guess, huh?
yeah, ideally I would want to um what do you call it? Do like self-driving cars, like at
Nice.
least help out on that. That's like my main goal.
Nice.
Either that or actually create my own startup for robotics. I don't know.
Dude,
So
no, that's sick. So
yeah,
out of 183 questions, how many? What's the breakdown? How many easies? How many hards? How
I
many
think
mediums?
yeah, it's mostly I think I'm around 100 mediums, like
Oh yeah.
90 easies, and then like 3 hards or like stuff like that. Like let me check actually
Then
my
you
breakdown.
just got straight into the mediums then, huh?
Yeah, I just went. Yeah, honestly, it like like so as of right now, I can only like I can figure out most of the time like the patterns, but sometimes most of the time I choke on like actually implementing like in like the more like problems that need like specific intuition into it.
Yeah.
So yeah.
All
Okay,
right.
so my breakdown is medium 107, 80 easy, and then 11 hard.
I see. Nice. So the only company right now that you're prepping for is Amazon. So you just have to hit like land this
No,
Amazon or
that's yeah, like honestly, after Amazon reached out to me, I was like, why don't I apply to like practically everywhere and check uh my like how attractive quote unquote I am.
yeah.
So Microsoft wants a phone screen. Google actually also wants a phone
Oh wow.
screen. Um, and then Meta rejected me. But I have like a couple of interviews for like not necessarily no name companies, but like non-tech companies as well.
Yeah.
So
I mean, it's a good strategy. You should, since you're already prepped, just try to get into as many company or try to get as many interviews as you can, because
yeah, yeah,
you'll have multiple chances, and you're just gonna get better and better.
yeah, exactly. Like I did my first mock ever like last week, and this is like my second mock.
Oh
So
wow. You just found a friend to run the mock on you?
no, I got like a freebie at like interviewing.io.
I see.
So it was a pretty, I mean, it wasn't hard, but like I needed like faster reasoning and like faster implementation. So
Yeah. Okay. All right. So I'm gonna post in the first question,
cool.
and you're pretty much going to have about. We're gonna try to work through 1 to 2 questions. Probably spend 20 to 25 minutes on each question,
All
just
right.
so I can get a sense of how you are with like two different questions. So
Cool.
focusing on more breadth over depth. But yeah, I'm gonna post in the first question and run it through like you would do in a regular interview. What language do you like to use?
Python.
All right, sounds good. So this is the first question. What we want to do is reverse the words in the string. So you can see
Okay.
how all the words are reversed. So it goes blue is sky the when it used to be the sky is blue.
Yep.
Yep. And if you can solve this fast, we can move on to a different one. But yeah,
Cool.
you have up to 25 minutes on this.
Yeah. So let me see here. Okay. The first thing that I noticed in terms of just like edge cases is like the white space. Um, so in terms of the output, we want to remove like leading and trailing white spaces and have proper spacing in between. Like for example, here at it asks like we remove like the 3 white spaces,
Yep.
right?
Yep.
Okay. Do we need or do I need to account for non-alphanumeric numbers?
Good question. Let's assume everything's just English characters.
Okay.
Not like ones or no digits.
Okay. Yeah, let me see here. In terms of like naive solution, to be honest, I think we could just trim so that removes like the leading and trailing white spaces and then split uh, so that it turns the entire string into words split by like the spaces.
Mm-hmm.
Um, don't know the behavior of split in this case where there's 3 white spaces, but uh, And then in that way, you can use 2 pointers to just like switch all of the, honestly, or you can even just, can you use reverse? Yeah, I think you can. You can just reverse it using the reversed method / function, I think. That's, I think, in terms of naive solution is what I would do. And then I think in that case, what it would be O of n, right? And then space complexity would be O of n as well. So let me see here. In terms of an optimal solution, you could just, how would that work? So we can traverse the string like index by index. And then if we are not or if we come across an alphanumeric character, that means that it's the start of the word. And we can just build the word itself using that. So like for here, like for example here, figure out that this is, or actually this is a better here. We keep going, we do like a loop through the entire string, and then just keep going. There's this white space, and then the moment that we see an alphanumeric character, we create a new, we insert into a variable and just keep on adding into that variable until we meet another white space, and then we add that to like an array.
So what was wrong with your first approach?
I mean, there wasn't necessarily anything wrong with it. It was just a more like it just uses a lot of Python functions. Are you good with that
Yeah,
approach?
I'm good with that approach. So
Okay.
could you explain it again? So you're gonna strip it, then split it.
Yeah,
And then what?
yeah, and then you could just use the I believe it's called reversed function. Like it's a reversed function to actually reverse that split, that list. I don't know if that's how it works. I rarely use that function anyway. So let me actually try that.
Yeah, go ahead and try that approach.
Okay. Let's see here. Reverse string. And then it's a string. Oh, words. Okay, let's just do S here. All right. Okay. Trim equals S. So just, I've forgotten how to use. Could I use the AI?
Yeah, you can use the AI.
Oh, it's strip.
Mm-hmm.
Strip. Okay, so then that creates a list. Let me see how that behaves with this example here.
Mm-hmm.
So that I can see. Oh, I'm dumb. Why does it look like that?
That's good now.
Oh, okay, cool. All right, so it does actually not remove the white spaces there. And here, just for confirmation. Yep. Okay. So then we do what is it called? Why am I blanking out? Split or I've forgotten
What do you think about the how to?
the method for actually splitting it. Isn't it just split?
You could ask the AI.
Yeah.
I like this AI.
Yeah, it is. Okay. Split, and we split on white spaces. So then let's just run that and check that. Yep. Okay. And then let me try this one, see how that behaves. Interesting. Okay. So it does. Let's see. Okay. I mean, it's reversed. Oh, reverse iterator. I guess the E. Let me just do it the other way, right?
Which other way?
It's just looping through the entire for word and split, rather than using like the reversed function. Because
What's wrong with the reverse function?
we technically, so for example, like this one right here, the split is actually putting in like empty strings in between.
Okay.
So we need to account for that anyway. So we might as well just use a for loop and determine if it's actually a word or not.
Like, how
So
can we modify the split in order to not do that?
I'm not familiar. Is it? Let me look at the AI.
Maybe ask the AI. Like ask the AI for the doc string on that.
The what? Sorry.
Or it says the summary of the split method. It tells you this. It gives you a summary of what the split method actually does. Try to read that description and let me know what you think.
Right. You're specifying the maximum number of splits.
What about separator?
I mean, in this case, the default is any white space. So we can just not put anything in here, and then it would just do that. We would just remove the, oh, it is. Okay. I'm asking the AI something else specifically for the reversed. Oh, okay.
Yeah.
And then,
Do you know what an iterator is or an iterable in Python?
yeah, well, not in Python, actually. So that I rarely use this one, but it's a good learning example. Good. And then so you want it in as a string, actually, not a list, right?
Mm-hmm.
Can you just do it that way? Or actually, no, that's not the right way to do it. It's and then join, leave, spaces. There you go.
Nice. Okay. Here's the follow up. down here, 26.
String data type is mutable in your language. Can you solve it in place with O1 extra space?
Yep. We could just talk about it. What would be your approach?
Okay. Interesting. Yeah, so then this would O1 extra space, huh? So then I think my second solution would work this out properly. Like if we loop through the entire string to figure out if we're looking at the start of a word, which means that we check if the index currently is storing an alphanumeric.
Mm.
That means that we're storing a word there. And then
Then what?
ooh, I guess it could be like a 2 pointers, right? We point it at the end, or we have something that's always pointing towards the end, and then we just append it. Like the left pointer is the one searching for the word itself, and then we append it to whatever the right pointer is pointing to.
Wait, what would that look like here? Like, could you show me here? Like if we had like a left pointer and a right pointer?
Yeah. So right here, okay. So here, our left index is has realized that we're at the start of a network because it's an alphanumeric. So then we store that variable at the very beginning, or we store that index at the very beginning. So in this case, we have like a variable that's like left start equals 0, right? And then we loop through, we keep going. Left becomes 1, left becomes E. And then at this point, we realize that we're no longer, or we have a white space. So then we do left minus 1 would be 2, right? And at this point, a word is complete. And do we, I think since in our right pointer is what? It's at the end.
It's at the end.
Right. So in this case, I mean, I guess you don't necessarily need to. You could just delete this entire thing, cut it, and then add it like s plus equals like.
Add it to the end here?
Yeah. Well, in Python, that wouldn't work because strings are immutable.
Or we're assuming space is immutable. Or
Oh,
mutable.
right. Makes sense. Yep. Yeah. So then you can just add it in like rather than just like not having the R. Or you don't even necessarily need that R anymore, right? Because then you're like s plus equals like stir left start to left. Actually, in this case, you would need.
But then
that.
Isn't that using up extra space?
Oh, okay. Okay. Oh, okay. I got you. So then that means that
why would that use up extra space?
Technically because you are storing, because you're adding like a duplication of the current word that you're at. So that's why it adds extra space there, or at least that's why I think you think it adds extra space, right?
Yeah, the array by the end of it is gonna be double the size.
Yep.
So double.
Yep. Yeah. So in this case, then
it's using over and extra space, like depending on the current size of the array, it's gonna be double.
Right. And then in this case here, then so to not use any extra space, then we also would want to do the same thing for right and figure out the like a right start and then a right end, right? In this case, I don't know how long this string is. but we loop through like in reverse technically here, right? In this case, E is alphanumeric, so we keep on going, right? We keep on going until we get to a white space. And then at that point, you swap your left pointers or the left and right word. Does that make sense?
Wait, could you repeat that? You're gonna swap.
Yeah. So like we do the same thing with the right pointer, and we figure out like how big the word is, right? And in this case, at that point, once we actually figure out that we have a word completed with the right pointer, we swap the left and the right.
How are we gonna swap the left and right word?
Using these right here. We keep track of like the indices of where the words actually start and end. And then in that case, that might also, yeah. I mean, that does pose a problem when
What
they're like
different lengths, right?
yeah, exactly. That's what I was about to say. That does, because then at this point, it might. Ooh, this is such an interesting follow-up. Mm-hmm. I'm a little stumped right here. Yeah, but is that kind of like what you were envisioning in terms of
I see what you're thinking. You're trying to swap word by word. So you're trying to find the
yeah,
first word and trying to find the last word and then swap them and
right,
find the second word. And the like the second word and the second to the last word and then swap them. But
right.
it's tricky because they're not the same size.
Yeah. Hmm. Yeah, I still think that we trim, right? That still is the same. But the two pointers, I think, is the only solution here. I don't see
Mm.
any other way that we could really,
Yeah.
yeah.
There's a two pointer solution, but I don't think you're like it's slightly different than what you're thinking here.
Oh, really? Okay.
But
Okay.
yeah, let's go. Let's move on to the next question
Cool, cool,
actually,
cool. All right.
because we're already 20 minutes on this. We're gonna switch to a graph question. Makes it easier.
Perfect.
Is that your strong suit? Strong suit?
Not necessarily,
Okay.
but I find them more intuitive. I hate strings, so this is like my worst case scenario.
Yeah, yeah. Strings are pretty difficult. This is a classic. You might have seen it already.
Oh, I love this one.
Oh, you've
Not
seen it?
necessarily. Not necessarily like it's been a long time since I solved it though. Not gonna lie. I think this was like I went through like neat code,
Yeah.
and like this was one of it, and so it was like the last time I reviewed this was like a month ago. So this would be a good refresher because it's pretty complex in terms of like
Okay.
what you need to do. Okay. So I'm gonna let you.
Yeah, it's here. This is the heights.
Okay.
This is the first example.
All right. Oh Lord,
It's long.
it is a lot. Okay. So we have our input is an n by n matrix, and the specific problem that we're trying to figure out is give the specific coordinates within the matrix that is actually able to reach the coast, quote unquote, either the Pacific Ocean or the Atlantic Ocean. And the only way that, and the criteria of whether or not they can reach the Pacific and Atlantic Ocean is if there's a path, I think a decreasing path, right, from wherever the oceans are.
Yeah.
Okay.
I mean, let's get into the drawing so we can explain to chat because it's a lot of words here.
Yeah. You want to draw it?
Yeah.
Where's the drawing? Okay.
So pretty much there's the Pacific Ocean.
Yep.
The Pacific Ocean is here. We have it in blue. Or is this
Yep.
Atlantic? Whatever. And then this is the Atlantic. So
Yep.
we want to see which cells will actually flow to both the Pacific and Atlantic. So pretty much we just how it travel, or if it rains, we want to know which cells will
Yep.
like empty out into both oceans. So
Yeah,
what's the condition for it to like move down? So pretty much the neighboring cells is less than or equal to the current cell's height. So for
Yep.
example, one of the ones is 0 and, or let's look at this one, 5.
Yep.
So I think at 5, 0, 1, 2. Okay, at 5, it flows into both oceans because from 5 it goes to 3, it can go to 2. And then it can flow down this way.
Yep.
So it can only go from less than or equal to, I think. Less than or equal to. Yeah, it can flow like from a higher cell, it can move down to a neighbor if it's less than, or if the neighbor is less than and equal to it. So you can just think, yeah, it's basic physics, I guess.
Yeah, that makes sense.
Like it's never gonna like be able to go upwards to
Right.
neighbors.
Yeah. Okay. So
Yeah.
the insights here, I'm gonna write down. So for key insights, right, we're dealing with a graph, which means that we're either gonna have a solution of depth first search or breadth first search. I believe you can do both here. In terms of optimal, I don't think there is any difference between the two. But I think the strategy is rather than actually looping through the entire matrix, right? And I'm gonna draw right here. Like rather than looping through the entire matrix, you actually start from where the oceans start. That way, you technically already have, or it's much easier to figure out from like source of where potentially any coordinates can reach any ocean, and then at that point, right, we collect coordinates that reach the Pacific Ocean, and then coordinates that reach the Atlantic Ocean, and then at the end, we wherever we're storing those answers or those coordinates, we just pick the intersection of those two lists, and that way we get what coordinates actually reach both. Does that make sense?
Mm-hmm.
So honestly, depending on how you want me to solve this, I can see a depth first search solution or breadth first search solution here. So how do you want me to solve it?
Which way do you think is going to be the best?
If I remember correctly, depth first search is easier implementation, but I've forgotten how to do it. But breadth first search is also, like, I think I learned this with breadth first search. And I do want to try with breadth first search because I don't, like, DFS is not, well, technically, like, I've done DFS a lot, so.
Okay. You're gonna perform BFS from where? Like, how is it gonna work again? Could you
Yeah. So we're gonna queue up all of the coordinates that are like touching the Atlantic Oceans,
Sure.
or Atlantic and Pacific Oceans, right? We're gonna have two arrays. Let me actually undo that. So we're gonna have two arrays of different colors, right here, right? So we're gonna store all of those into, I believe, the queue. Yeah, right. A queue. And then we just go through the directions and keep on trying any coordinates that have
Okay.
what is the
I see.
condition?
All right. I think just go ahead and implement it. It makes sense. You're going the right
Okay.
direction.
All right. Pacific, Atlantic, and matrix. Right. Okay. Let's start with some variables. We have directions here. So this stores like the directions that we would need to calculate. So we can go up, we can go down. Or technically that's left or right. And we can go up and down. So these are the directions that we're going to be looping through in our breadth first search. And we need our lengths for the rows and also the columns. And then here, we need to loop through and figure out, or actually, yeah, I'm gonna I forgot this. What is he? Atlantic.
Which level are you interviewing for again? They're asking, chat.
For Amazon or for all of them?
Amazon or all of them, yeah.
Yeah, SEE2.
Okay, nice.
I think we loop through.
You're gonna have to prep that dynamic programming for Google.
Yeah, I know, which I'm afraid of because I never touched it, or I rarely touch it, to be honest with you. I've forgotten how to set this. I believe it's like this. For range rows. Equals I think you said it like that. So these will store can reach. This will store all of the rows that we will actually or coordinates that can actually reach each ocean. So we're going to establish deck here, or DQ technically. Is it from collections? Import deck. Go in queue. And then, okay. So for row in rows, in range rows, or actually, yeah, in range rows. So here we're going to add everything that is in the coasts. Full in range, no. Let me see. You append.
Yo, Alex, long time. Are you still interviewing?
Matrix. So we're going to start. So here we're going up. Okay. So 0 and then full is -1. So that one. Yeah. Okay. So this goes through and adds in all of the wait, hold on. I'm tweaking. There we go. I got it. Okay, so these two lines add in and append all the coordinates that are touching the left side of the matrix, and also the let me see here. So that I can actually have visual aid. Okay, so row. Yeah, so this is going to touch like the Atlantic or Pacific side, this part, and then also add in this part as well, the ends, right? So the leftmost side and the rightmost side, the edges of those. And for coal and range coals, you append matrix 0, and then coal, and you append matrix rows -1 coal. All right, so those pretty much both of them add into the queue like all of the edges, pretty much, because we technically know that those reach each ocean, or at least one ocean, right? I'll queue. Okay, here we go. Right, we're gonna cur. Oh, wait a second. Am I doing this wrong?
Yo,
I am
congrats,
doing
man.
this
That's so
wrong.
cool. Google Developers Group. That's really sick.
I messed up. Okay, we need to store the rows and columns. That's where I messed up on. Rather than like pulling it out, we're just gonna do it this way. Sorry. So we're gonna create a tuple for these. Per equals q.pop left. Because we're doing breadth first search, we do pop left. And then for your row and your col and directions, right? So we're going to store. Okay. Yep. So we calculate the new row and new column. Your for row for column plus direction column. Right. So here is the meat of the solution. Right. If you 0 is less than or equal to, or less than new row, I think it's equal to, or Yeah. And then rows and 0 less than or equal to new column hold. And here is where we do the comparison. That is very important, where because we are starting from the end or the beginning and to the end, or yeah, since we're starting from the beginning, we have to flip that comparison. I'm trying to find the comparison here. Where is it? There's a lot of, where is it? It can flow if the height is less than or equal to the current cell's height, right? Okay, so the comparison here would be if matrix row and curve and current column is less than or equal to new row, new column. So this then believes I believe you just end it or add it technically. Append new row, new column, right? Is that it? I think that's it. Actually, hold on. If it is, we also okay. Because at some point we have to use these can reach Atlantic and can reach Pacific. I think we use it here.
Use it where?
Yeah, I think we do. Actually, do we? Let me just skip right by that because now I know that this actually will start appending into the queue everything that reaches the criteria or reaches at least one of the oceans. Oh, do we have to set all of these to true as well? Actually, I think. Okay. Let me just skip through this.
I mean, you have the BFS here.
Yep.
But how would we know that if it could touch both of the oceans or not? Because we need to return which cells could eventually reach both the oceans.
Yeah.
Right now we just have sort of boilerplate BFS.
Yeah, this is pretty boilerplate. I'm trying to figure out what use because we also at some point do the intersection, right? I think this is we can use like the can reach Atlantic, can reach Pacific list as our kind of like visited.
But like, how would we actually use those?
I think here when we do the pop, we put that into the can reach Atlantic or can reach Pacific. But or do we need two queues? No, I don't think so. No, that's impossible. Yeah, I think you do at some point here we do want to use these can reach Pacific, can reach Atlantic. I think it's right here in between. How do you determine if it's the Atlantic or the Pacific?
This is a
That
problem.
question. I kind of regret my choice. Maybe depth first search was the.
What would make the difference if you use depth first search instead?
All right, you caught me in another lie. I actually um let me think.
So I think your problem right here, right now, is when you're performing your BFS, you're
Yep.
looking when you're looking at a cell,
Hmm.
you don't know where this cell came from. Did the cell come from
That's true. From the Atlantic or
Atlantic or the Pacific? Like who NQ'd it? Was it somebody from the Pacific or somebody from the Atlantic? At the end of the day, you need to know both. You need to know if it was NQ'd by both the Pacific or and the Atlantic.
okay. So then I guess we need to add a marker to the tuple. Then, um, in this case,
Well, what if we just perform a BFS from one of the oceans and then see where it gets to? See what cells it could reach from that specific ocean.
so you're suggesting two Qs then?
So pretend we did a BFS from the Pacific Ocean.
Right.
Then we'll know all of the cells that can actually be reached by the Pacific Ocean, right?
Right.
So now we know that for sure. And then
Right.
how do we check the Atlantic? What if we do the same for the Atlantic and then you just take the intersection?
Uh, let me
It's like
see.
it's like a two BFS solution. Two.
Right.
Yeah, we're pretty much at time though. So
No. Okay.
how did that go for you? How was that?
Um, honestly, it was fun.
Mm-hmm.
Um, I wish yeah, it definitely like this. I love graph problems. It's just like I've forgotten like the intuition on this one or how
Yeah.
to implement it in graph first search. Like the first part, honestly, like the first question was pretty fun to me,
Mm-hmm.
just because like that follow up was very interesting. And obviously like in the real interviews I would get follow-ups, right?
Yeah.
And so uh yeah, I just liked having to think that way. And
Yeah.
I to be honest with you, like strings are the bane of my existence. So it was good practice to really um work with strings because generally I try to avoid them
Yeah.
like in my practice.
Yeah.
So, but yeah, it was fun. I
Mm.
liked it.
Okay. Yeah. Let me go through the feedback. I think you definitely clarified the question well. So
Hmm.
you started off. You have a good process clarifying the question, posing the or telling me the naive solution and maybe ways that you could improve it.
Uh,
And then I think you said the naive solution. You said the
mhm.
kind of the optimal solution, then said it was naive, and then
Oh, really?
continued to look for some other approach. But then you were going a bit off track, but you had
Okay,
a good approach at first. I think you
gotcha.
just need to do more practice on strings because you need to
Yeah,
memorize the common string functions. You need to be able to know how strip works, how dot reverse
yeah,
works, how reversed works and returns you iterable, how split works and where you could like not include a parameter, split by all white spaces.
gotcha.
So
Yeah,
just understanding all of the common string functions, you
mhm,
shouldn't be able to look it up because, or you shouldn't need to look up the common string functions
gotcha.
eventually. So it's just more practice. Like you knew what it was, but you just had to look it up. So that just tells me that yeah, you just haven't used them in a long time.
Yeah. I was honing in on more patterns that were like, like binary search, things like that. So yeah, I definitely need practice on string manipulation. So yeah, that's good feedback.
Yeah. So just prompt GPT. Like,
Uh-huh.
what are all the common string functions, and then just
Cool.
memorize those, or
Gotcha.
just learn by doing too.
Uh-huh.
So just do some basic string functions, or when you're practicing, do basic string questions at least a couple times a week. I know they suck. I hate them too.
Yeah.
Let's see. So when it comes to the second question, yeah,
Uh-huh.
you understood the solution, but yeah, you mentioned you've seen it already.
Yep.
So one thing I would watch out for in the interview is if you've seen the question before, you should still pretend that you've never seen it before, because
Okay.
well, like the way that you kind of explained the solution, I could tell that you've
Mhm.
seen it before. Regardless, like if you even if you told me that you've never seen it before, I would have knew you would have seen it before. Because when
Right.
you're, for example, when you're writing the the queue, and then you
Mhm.
got to the part where like you had to flip the comparison, you're just writing the code pretty much from top to bottom.
Yep.
You're like, oh, this is where I need to flip the comparison, instead of
Got
saying why we need to flip it. So
Mhm.
instead of saying, oh, this is where we need to do it, sort of like because you memorized it, instead frame it in, oh, I think we need to do a comparison here. I think we'd have to do in the reverse because we're going from the oceans to inland. So if
Gotcha.
it's not reversed, then we'd be going in decreasing order from the Pacific. So have like an explanation like that that's more specific, or that doesn't sound like you memorized it.
No, that makes sense. I was, I mean, I was definitely trying to actively recall the solution
Yeah,
there. So,
but yeah,
yeah.
you have a good boilerplate BFS with
Mhm.
the directions, with the way you generate the can reach arrays
Yep.
and loop through it. But yeah, I think just being able to, you just didn't get to the right solution, which
Mhm.
was performing a BFS from the Atlantic, and then performing a BFS. So when you BFS from the can reach Atlantic, while you're doing the BFS, you're like setting all of the nodes that you can see to true in the can reach Atlantic,
Oh, it's true. Oh, okay.
and then you do the same with can reach Pacific, and then after
Gotcha.
you just loop through the grid, and if any
Uh-huh.
cell is true in both, you return that
Yep.
result. But yeah,
Gotcha. Okay. So I initialized it.
yeah. I think the
Uh,
good thing is you obviously clearly know how to code. You just
yep.
need more practice on the algorithms. So it's
Yeah.
just more just fi- learning all the patterns, or yeah, just the problem solving aspect of it. But at least you already know how to code. You don't have to even think about that when you're
Yeah.
doing the question.
Yeah. Like I said, I just need to hone in a little bit more on the patterns. And yeah, cool. Thank you
Cool.
for the all the
All right,
feedback.
man. Good luck. Let me know if you need to do another one. When's your interviews?
I for sure need another one.
Yeah.
I'm still trying to schedule the Microsoft one.
Oh, you got a
Um,
Microsoft one too? Holy,
oh
yeah,
yeah.
all of them. Google,
Yeah,
Microsoft.
bro, I honestly like if you look, I don't want to dox myself, but
Yeah.
you like see my name. But like if you look at my LinkedIn, you like check like my resume, my personal website. Like to be honest, I was not expecting to like get callbacks from like Google or Microsoft. Like
Yeah.
I literally come from like a no-name state university.
Mm-hmm.
So like it was very shocking to me that they actually were like responding. So
Yeah.
yeah, like I that's why like I'm like so nervous at like trying to do these mocks because now
Bro,
like it's actually getting real and I
yeah.
never realized that I could actually like get callbacks from them. So
Bro, you might get three different, all three of them, and compete, make them compete against each other for salary, and
that'd
come
be the
out
dream.
come out in 2026 making a crap ton of money. That'd be crazy.
Well, the only thing is like I'm trying to push out Google as much as I can because that's like the dream, right?
Yeah.
Like I would rather be in Google than any of them, to be honest. So I'm trying to like delay that. I was like, hey, how long can I
Yeah.
prepare?
Chat's asking what your resume looks like.
I can send it. I can anonymize it and send
Yeah.
it to you.
Send it
And
in
then you can
the
tell
resume
me.
review. Or oh yeah, I'll email you.
Okay, cool. Yeah, I
All
can
right.
email. Like, to be honest, guys, like it's like I think I just know how to word my impact because I actually do have a good amount of impact in my
Mm-hmm.
current team or in my current company. I think that's literally it.
Yeah.
So I
All
think
right.
the best thing is like if you can wordsmith your resume, I think it like which I just realized is like it does matter more, to be honest.
Mm-hmm.
So
Yeah. No, good luck. You should schedule another one. Continue
oh, I
practicing,
definitely
and
will.
yeah, we'll work together to get you prepped for these. For sure, you're gonna get it. I like doing these interviews,
Yeah.
especially when someone has something a month away, where we can go through multiple sessions to just see how they improve.
Yeah, I'll definitely let you know. I'll probably schedule another one. I just want to learn from your feedback.
Mm-hmm.
So I'll probably give it like a week or two. I
Yeah.
have like a no name company interview like this
Nice.
Friday,
Yeah.
so I'll do that. Practice some more, and then I'll definitely come back for sure.
Yeah. No, that's the best strat as well. Take a bunch of interviews at companies you don't care about
Yeah,
as well.
yeah,
Just get your reps in because you don't want to go into the Google interview and it's the
yep.
first interview you've ever done. You're gonna choke.
Yeah, yeah, exactly. And I don't want that cooldown, bro. Amazon, I
Yeah.
don't care about the cooldown. Like, I wanted to schedule my Amazon interview first, just so that like we all know how Amazon is. So,
Yeah.
I would rather take the hit there than Microsoft or Google. So,
Mm-hmm.
cool.
Cool. All right, man. Good luck.
All right. Thank you.
All right.
Have a
See ya.
good one.
Bye.
Bye.
Yo, chat. He has interviews everywhere. That's insane. Why Alpha? Yo, Ash. What's up?
Yeah, what's up, man?
How you doing? You ready?
I'm doing good. Yeah, I'm
This is our
ready.
third one.
Yeah, third.
All right. Let's see. What did I ask you last time?
What did we do last time? The binary tree one with the left child and the right child,
Oh, I see.
validating the binary tree.
And then what else? Was it just one question?
Yeah, just one question.
Okay, and the other time I asked you about backtracking.
Yeah, the other time we did rotting oranges and then generate parentheses.
Okay.
Yeah.
All right. Perfect. How are you feeling now? Do you think you've improved since last time?
Since yes, I think we did it yesterday, right, or Friday.
Maybe. Yeah.
I haven't gotten a chance to like do a lot of problems, but I've still been looking into graphs since the last call.
Okay.
Yeah.
Give me a sec. Let me find some good questions.
Okay.
Hey everyone. So today this is part 3 of training up somebody for their Amazon interview. So we already did 2 interviews before this. The first one I asked the backtracking question, which is generating parentheses, rotting oranges. And in the second session, we did validate binary tree nodes. So we did a backtracking, we did a BFS and sort of a DFS one. And yeah, we're gonna continue from there, testing all the different aspects of this person's algorithms knowledge. Let's work through. I'll post in the first question. Oh, I forgot to give you the link.
Yeah.
I'll give you the link and then hop in. Nice. Cool. Use Python, right?
Yes.
All right. So this is the first question.
Okay.
So we're pretty much gonna be given a robot in an M by N grid.
Uh-huh.
The robot is initially located at the top left corner, and the
Mm-hmm.
robot's job is to try to move to the bottom right corner.
Mm-hmm.
The robot can only move either down or right at any point in time.
Mm-hmm.
We need to tell me the number of possible unique paths that the robot can take to reach the bottom corner. And I can draw this out for you.
Okay.
So it'll make it a lot easier to visualize if I draw this out for you. So pretend we have a robot like this. Or we have a grid here.
Mm-hmm.
And then we have this. One, two. Right?
Yeah.
So the robot's going to start here.
Mm-hmm.
And we want it to end here.
Okay.
And it could only move right or down.
Okay. And
Right.
that is that the only limitation on its move? Is there any obstacles in between?
No obstacles in between. So basically the answer is 28. There's 28 unique ways you can get to E. Maybe this is one.
Okay. Yeah.
Maybe
And then
like this.
Okay.
Two.
Mm-hmm.
Maybe like this. I mean, there's 28 unique ways.
Yeah.
Yeah. Okay. What are you thinking?
So I'm definitely thinking DFS for this. But let me think this a little. So if we do DFS, we'll probably just have a track for what we've already visited, so that we avoid going on cycles. And then we can just start visiting each node, and then just explore, like diverge into different paths. If I were to do that with BFS, then I would, starting from the origin, I would just take out the possible nodes from the origin, and then I would go level by level. So for each of the nodes in the current level, I would take out another level based on that. But it's got to be sort of a headache to generate all the paths through BFS, I think.
What
So I think
what would be the time complexity on that?
Okay, so basically we are going to are you asking about the BFS?
Or any of those DFS
I think
or BFS?
it's going to be M by N, assuming like that's the size of the matrix, right? Because if I think about it, if once I go here, I can go here. And actually, it's just going to be limited by the total number of possible paths, I think.
Yeah, the total number of possible paths.
Yeah.
It can get pretty large, I think.
Yeah.
It's pretty exponential. Because at each it breaks out into 2 branches.
Yeah, exactly. Oh yeah, I mean, if you think about it like that, it's going to be 2 to the power n, I think. Yeah, so if I for DFS, I'll probably start from the origin and then look at what possible paths I can take, and then I'll maintain a visited set, and then from each of the node I'll again do the same thing. But I'm just trying to think if there's any nuances, because like for example, if I take this path, I'd also have to pop
Well,
from
it can't
the
go
visited
backwards. Can't go backwards like that.
Yeah, it can go. Oh, it can only go right and
Yeah, right and left, right and down.
right and left. But I think I'm ready to implement it. So basically, keep track of visited and then just keep like exploring the 2 possible paths from each node through depth of search.
It's not a efficient solution. It won't.
But
you won't finish in time. Yeah.
Okay.
It's not
Okay.
efficient.
Okay. In that case, let me think about it. Okay, so let me draw this grid again.
Or you can Command Z. It's gonna start deleting all that.
Okay.
Yeah, there you go.
Okay, so if we can't explore all paths, right? There has to be a better way. If at each point we can only explore right and bottom, from here I can only go here and here. Here and here. Um, then potentially, like maybe I can do the BFS approach.
Well, the BFS approach will still explore every possible way. Like if we do any traversal.
So you're saying like it's possible to get the answer without truly like exploring everything.
We need a better algorithm than exponential.
Okay. Is it potentially DFS with memoization, or are we caching like previous visited paths, something like that, maybe? Or is that like, is there something more like like greedy or something of that nature?
Try to break it down into a smaller example that you could work with then.
Okay. Okay. Yeah, that's so that kind of leads me to think that it might be a DP solution. Okay, so yeah, so if I were to ask the question, how many ways I can reach here from the start node, I would say there's one way, because I can only go here. And then if I were to ask the question, how many ways there are to reach this?
Like what I mean by that is, okay, let's work with what if we had a one directional. Let's start. How many ways does it take to reach this end?
Mhm.
How many unique ways?
Yeah, so so the question that I'm asking is basically like, if I were to start from the starting node, which is this node, right? This one. If I were to go from there to the start node itself, it would just be, uh, you don't really need to do anything because you're already there, right? It's 0. And then if I were to go from start node to this place, it would be that plus 1. And then for this, it will be 2. And then for this, it would be 3. But if there's another row to the
So the
grid,
answer there is 3. Well, could you reverse that?
uh,
Well, the
oh,
answer.
sorry. Yeah, actually, my bad. I think I'm asking the wrong question. Sorry. Yeah. So the question that it's asking is the total number of possible unique paths that the robot can take to reach the bottom right corner.
Yeah.
Yeah. So it's going to be just one, basically.
Yeah. There's one path you can go like that.
Yeah. There's one path. Yeah.
Okay.
Uh.
Let's work through a smaller example.
Mhm.
What if we had a small example like this? How many different ways? Do you see this example?
I see what you're drawing at the bottom. Yeah.
Yeah. So how many different ways can this be solved?
Wait. Where are you drawing?
Oh, you don't see? Oh, try refreshing your screen.
Okay. 1 second.
Like at the bottom.
Okay. Yeah. So yeah. So okay. Let me. So this is a 2 by 2 grid, right?
Yeah,
and
so
then
2 by 2
we're
grid.
starting from here, and then we are ending here.
Yeah.
So starting from here to here would be 1. Here to here would be 1 as well, and then uh, um, going from here to here would be. Well, I mean, if you're
Yeah. How many ways can you get to this cell?
Yeah, I mean, you kind of have to add like because you can do or you can go right and left only, right?
Yeah.
So sorry, right and down only. So it's going to be 1, and then here it would be, you just have to add this and this, so it would be 2.
Mm-hmm.
So right down and then down right. So that's 2. Yeah, so that's probably our how our DP is going to work is
Okay, let's go back up to this big example. So how would we solve this big example?
yeah. Yeah, so you start from this node. That's going to be one way to get there, and then this is also going to be 1.
Mm-hmm.
All of this is just going to be 1. And then for the bottom row, it's also sorry, the second row is just going to be 1, and this is going to be 2. This is going to be 3
What is this
because
one
we
gonna be?
Uh, that's going to be 1 as well.
Okay. Yeah.
Let me see if that's correct for the
Yeah.
3.
And
So it's going
keep
to
filling
be
it out.
okay. So for the 3, I'm just going right, down, left. That's 2. Down, right. That's 3. Yeah, let's see. That's all I can do. So I think this probably works. So 4, 5, 6, 7, 7, 8, 9, 10, 15. 15 plus 6 is 21, and then 28. Okay. Yeah, I think this works. I can
Yeah.
probably
Go
code
ahead
it
and
out.
implement.
Okay. So um, we have M and N. Mm, uh, and then DP 0, 0. Okay, set the first row, sorry, first column to be 1, and then there's probably a neater way to do this, but 0 j equals to 1, and then for I in range 1 to M, for j in range dp this is going to 3 minus 1 plus dp I minus 1. Okay, so create the row, which is just going to start off as 0, and then create the dp array for the m. I just append the row to it, and then for the first column set it to 1. For the first row set it to 1 as well, and then the rest of the states will be dpij equals to let's see. Sorry. And oops. Wait, what am I? Oh. Huh.
Let's work through the actual example. Or sorry, I didn't give you the example. Call it with this.
Oh wait. Oh yeah. Yeah, I think it works. But I feel like there's probably a mathematical solution to this as well, since it's
Your solution looks good to me. What's your runtime here?
so it's just going to be m by n. So however many cells there are in the matrix. But there's going to be like some plus stuff there. But that's just going to be that's just going to like even out. I mean, it's not going to the overall time complexity is just going to be bounded by m by n.
Okay. Sounds good. Let's. I'm gonna put in the second question.
Okay. Yeah. By the way, is there a mathematical solution to this? I think there should be.
Probably, but
Yeah.
I think it's fine.
Okay.
I'm gonna post in the next question. So this is Q2. So
Okay.
I'm gonna post at the bottom here.
Okay. Okay, so you're given the root of a binary tree with unique values and an integer start. At minute 0, an infection starts from node with value start. Each minute a node becomes infected if the node is currently uninfected. The node is adjacent to an infected node. Return the number of minutes needed for the entire tree to be infected. Do you have an example for this?
Yeah, I'll give you an example. Pretend we have a binary tree. We're gonna be given the root of the binary tree.
Yeah.
All right. So pretend. Like this.
Mm-hmm.
Right. We have something like this.
Mm-hmm.
So we have a regular binary tree. Let's say and then we're also gonna be given the root that's gonna start to get infected.
And it can be at any part of the tree, right?
Yeah, it could be at any part of the tree.
Okay.
So this could be the started infected node. So
Okay.
so based on the problem statement, how long will it take
Mhm.
for the rest of the tree to be infected?
Can it infect the tree? Its parent, like
Yeah.
this one.
Mm.
It can.
Yes.
Okay. Uh, so you're given the root of a binary tree with unique values, and an integer start at minute 0, and infection starts from the node with the value start. Each minute, a node becomes infected if the node is currently uninfected. The node is adjacent to an infected node. Return the number of minutes needed for the entire tree to be infected. All right. So basically, in this example, in the first minute, this will get infected, right? This node,
Mm-hmm.
and then this will also get infected, and then this will also get infected. That's minute 1, and then minute 2 will be this and this. So it'll take 2 minutes for it to get infected.
Mm-hmm.
So yeah, I mean, in terms of how we can calculate this, um, so if we find the starting node first, um, let's say we first locate the starting node and then we start our exploration from there. We'll explore the left and right, and we'll say, okay, this got infected at 1, this got infected at 1, and then we'll say this will get infected at 2. So I think the traversal downwards towards the tree like is simple maybe. But the tricky part is how do we do the back thing, right? So this will be 0. Um, um, mm, 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 mm. Okay, so here it took 2 minutes, and then I'll probably do like separate runs for like the bottom, going towards the bottom, and then the rest of it. So through this, I can say, okay, like it took 2 minutes for uh the nodes beneath me to get infected. And then for the top half, I'll probably start from the root, uh, and then I'll just count how long it takes for me to get to the infected node. So this is going to be 1, and then yeah, this is going to have more stuff, right? So and then this will be 1. I'll count how much time it takes for me to get to the infected node or to get to the farthest leaf. So this is going to be 1, 2, and then 3, and this is just going to be 2. So the max time it takes for everything to get infected is going to be 3.
For where?
So in this particular tree for this example, the answer is going to be 3, right? Sorry, actually no, it's going to be 4 because 1, 2, 3, 4.
Yep.
Yeah. Okay. So I basically need to add. So I'll do the 2 steps that I said. Right. First is going to be from I'll find the starting node first, the infected node. I'll go towards the bottom. I'll get the max height from there, either for the left or for the right, whichever has max height. So this is going to be 2, and then what I'm going to do is start from the root and then go towards the infected node, and then I'll basically track. I'll stop when I see the either the infected node or get to the leaf. Either or, and then I'll just take the max of those, and then I'll take the max of this uh, uh, this exploration versus like this exploration.
So this one is gonna yield 2.
Yeah,
This
this is going to
first.
be U2, and then I'm just going to do max of 2, and then max of 3 plus 1.
Why is this 3 plus 1?
So the right side is going to give me 3, but I also need to track the distance between me and the starting node, right? Sorry, the infected node. So that's going to give me 1. So this is 3, and then this is 1.
Mm-hmm.
So the answer is going to be 4. Does that sound good?
Mm-hmm.
Okay, yeah, let
you
me
could try it.
okay, let me try it. Okay, def. Oh, do I need to write down the class for the tree as well?
Yeah.
Okay. Class node is going to be self sort right. No, actually, it has to be.
Or we could assume that we have a tree node class. Just write the algo.
Okay,
We
I'll
could
try
assume.
right now. Yeah, thank you. Okay. Okay, that's there. In that case, def time to action, and then we will probably be given the root. So find the infected node. So if root dot val equals to
Damn, everyone here is getting some crazy interviews now.
root dot val
Bro,
equals
this
to
chat is
start,
cracked.
return 0 or not root, return 0, and then otherwise I am going to say find infected root dot left, find infected. Okay, so start from the root node, go towards the left. If left is infected or not root, sorry. Okay, so either we're going to hit the infected node, or we're going to get towards the leaf. Oh, sorry, yeah, the leaf. If root equals to start. So in that case, distance to infected will be the distance, and then we'll just return. So if we For example, let's say this was the thing, then 1, 2, and that would be that, and then 1, 2, 3, 4. Return from there, and then 1, 2, 3, 4. Mm. Okay, so in that case, if it's not the infected node, then we just keep exploring, keep adding 1, 2,
Alex, I've folded a lot of
3,
people with this
4,
question, so I think
whatever,
it's
and then
medium.
that's just going to be the distance. Okay, let me just try to run this function and see if it looks good. Do we have an example to run?
We'll just dry run the code.
Okay,
So
so
to find
yeah,
infected.
yeah, so what I'm thinking is basically, so I'm taking it in 2 steps. First is like I'm trying to figure out how far down the infected node is, and that could be in either side of the tree, and then how far the leaf is. So that would be if my left side is infected but my right side is not infected, then this would give me that the distance of the leaf, like the farthest leaf, like this would probably be like max height or something. But that's going to give me that. So in this case, what I want the code to do is basically, so it's going to go towards the left, and then I just added the distance 1 to it, and then it's going to realize that that's the infected node. So it sets the infected distance to be the current distance, which would just be 1, and then it just returns from there. And then otherwise, basically, it's going to keep exploring downwards. So it goes towards the right, the left, and then at this point, it sees that okay, it's at the leaf. So it just sets the distance of leaf to be 2. But what I'm assuming is that since we are going to hit the farthest leaf at the end, this will always have that farthest the count, like the distance to the farthest. So this will have 3 at the end. So that's the first part of it. And then the next part would be to actually also I need to say that infected node equals to none, and then I'll just node equals to sorry, yeah. So I'll just set the infected node as well, and then now I'm going to say def max height node root comma height, and then if not root, return find infected dot left height plus 1, find infected root or right height plus 1, and then okay, let me see if this works. So so basically from here we start down here, left height 1 gets added to it, and then it says left and right, so that's going to set the height to 1. Then we go towards the right, and that's going to set the height to be 2. If there was more. Yeah, I think. And then what we need to do is from infected equals to max height infected node comma 0, and then um return max infected. infected. Oh, yeah, so this would be my solution. So I think there might be like like for the height calculation there might be one-off differences. Like
Okay, yeah. Try running me this code top to bottom. How does it work?
okay, sure. Okay, so what I have first is I can probably like explain with the drawing as well.
Or just walk me through the code here.
Okay, yeah, sure.
Uh,
So what I'm trying to get is first from the root how far the infected node is, and then how far if it's not infected, like how far the leaf is. So if the infected is towards the left side, I want to get the distance towards the leaf from the right side of the right side, and so on and so forth. So if I see that something is infected, then I just set the distance infected to be distance, and I'm just like increasing the distance here. Uh, and then I set the infected node as well to be that node itself, and then I just exit out of that. So once I reach this S, I just exit out. So if it's on left side, I just exit it out of there. And then if that is not the root, then I keep on updating the distance leaf. So at the end, I'll have the max height for whatever side does not have the infected, and then I just exit out of there. And then so that gives me these two things. And then finally, what I'm doing is from the infected, I'm just getting the max height of the tree, starting from the infected. So that's going downwards. And if it is not the root, then I set the max height to be height and then just return. And then I'm just like doing left right exploration of the tree. Uh, and then the answer is going to be either it's going to be however many the max height from the infected, or it's going to be the distance to infected plus the distance to the leaf towards the side where it's not infected.
I see. Let me try to run it.
Okay.
There might be some slight
Yeah, there might be
syntax
some
issues.
yeah, I'm kind of the height part might have like one off problems.
Chat said max height should be max height. Oh. Okay. Yeah, your max height. Don't think it looks correct. If not,
What?
so every time you see a leaf,
Mm-hmm.
what's happening?
Every time I see a leaf, I'm changing the max height.
Okay.
Uh,
Is there any issue you could see there?
Oh yeah, I mean, I feel like this might not be because I feel like that's not how you get the correct height. But okay, so if I'm starting from, let's say, like in a normal tree, uh,
Like pretend you have a tree like this.
yeah.
Oh shoot.
So I go towards the right. I keep adding one, right? One, and then I go here. I two.
Well, why are you going here first? Why are you going that path first?
Oh yeah, that's actually sorry, my bad. That is problematic. Sorry. So what I need to do is max height equal max max height comma height, and then probably so sorry. Max height comma height. So that's one place where I'm doing that, and then if without val equals to start distance infected equals to distance. So I think this one is fine for the distance infected, and then infected node equals to root distance leaf. So this also needs that update. I mean, this is also height as well, but this is also max height. But yeah.
Where?
So yeah, I made the same update here as well because it has the same problem.
What about here?
Distance infected equals to distance. So I don't think it needs it there though, because here we're only getting the distance to the infected node, right? So that's going to be correct.
Okay.
Yeah.
Is there any problem here with this? With just the syntax of the code?
Max height equals to cannot be assigned a declared type root unknown height unknown. But where is that coming from? This syntax. Oh my bad. Oh sorry.
What was the issue?
It's just that I'm reusing the name of the function. Yeah, and here as well.
Okay.
Max
So
height.
what's the time and space complexity? Let's start off with time.
Yeah, that's a good question. So obviously we are going to be exploring to the height of the tree, right? And then for here as well, we're just going down towards. Yeah, I think it's going to be bounded by the height of the tree.
For time?
Yes.
So what exactly does that mean?
Actually, one second. So we're basically exploring here, and we're also exploring all these paths. From here, we're also exploring all these paths. Since we're touching all of the nodes, maybe it's just going to be the number of nodes in the tree. Yeah, I think it's going to be. Yeah, I think it's going to be number of nodes in the tree. The total number of nodes in the tree.
The space?
For this, so for the time, it's going to be number of nodes in the tree, and for the space, so for the stack, for the recursion stack, we'll probably have So it's the recursion stack will not grow beyond the height of the tree, so that's the bounding factor. So it's going to be O of h, where h is the height of the tree.
Okay. Cool. All right, we're pretty much at time.
Okay.
How do you think you did?
I think I did much better than the previous ones. But for the first one, you definitely had to give me that hint that it was a DP solution, because the moment I saw that it was a grid and then robot, my brain immediately went to a BFS or DFS, because I've seen those problems where there's like obstacles in between and then you have to like DFS and so on and so forth. So yeah, so I think for that one I needed that hint, but for this one I think I did okay.
Yeah. So let's talk about the first question at first.
Yeah.
So I think you just need to work on breaking down the big problems into smaller problems. So you're looking at this massive example.
Mm-hmm.
So the only way, like the way that we were able to figure it out was when I started breaking it down. I gave you one row, then I gave you like a small 2x2 grid.
Yeah.
And then you were able to figure it out. So you should follow that same approach when you're interviewing.
Mm-hmm.
You they might give you a big example. It doesn't really make sense. So try to
Mhm.
work on a small example where you could figure out the answer
Yeah,
very quickly.
yeah.
You know what I mean?
I definitely need to like I haven't practiced DP at all. So I need to like separate out time and then just like do a couple of days just
Yeah.
like doing DP questions. But the reason I'm kind of like down prioritizing it is because I know like that Amazon does not is not big on DP. At least
Yeah.
that's what I've heard.
I mean that one's not the classic DP. That
Yeah,
one's just
yeah,
kind of
you're right. You're right.
understanding how to
You're right.
reason
That's the
about
one
it a
that
bit. That one's not like a classic DP question. I
yeah,
think
that
that one's
one
fair game for any company.
you're right. That one was very simple, yeah, for
But I
sure.
think just the concept of just taking down a small example
Hmm.
and then break it down into easier ones
Yeah.
is something you could work on the other ones.
Okay, awesome.
So yeah, overall though, you implemented it fast and it worked.
Hmm.
So pretty good. And then yeah, second solution, no real concerns. You're able to solve it and the code works. I think
Okay.
you did a lot better in the last since the last one and the one before that. In the last few days, you've improved a lot.
Yeah, because I think the nervousness also has gone down. So I'm
Nice.
hoping that translates to the actual interview as well.
Yeah.
Uh, but yeah, I definitely realize that I need to because usually when I do these problems these days, I'm not really thinking about like time and space complexity at the end. So I probably need to like work on that as well.
Yeah.
Just like the general stuff, right? Uh, time complexity of like exploring a tree and all of that.
Yeah.
So
And you
I
you have
definitely
you're interviewing for experience position.
yeah, I'm doing SDE too.
Okay, so you're gonna have to do system design then, right?
Yeah, yeah. I've studied system design. Like I did like seven. So I've been looking at that, but for the past week, I've just been focused on this problem solving part.
I see.
But I'm gonna look at that again.
Okay,
Yeah.
makes sense. Cool.
But I'm generally like a little more confident with system design than I would say. But yeah, I mean, I actually had I previously gave an interview at Amazon like in 2020, like 2 years ago.
Mm.
And yeah, I didn't get it at that time. But I was like super unprepared then. Like when I think about it right now, like I don't even know what I was doing back
Yeah.
then because even back then. I think like they put me in a SDE2 interview, and I didn't even have like a 1 year, so, like 2 years of experience back then. So I was like definitely misplaced, but at the same time, I was able to get through the phone interview and I got canceled from the final round.
Nice.
Yeah, so
Yeah.
hopefully this time it's better.
Cool. Wait, did you schedule one later too?
Oh, actually, accidentally I did that. I can cancel it.
Oh yeah. Okay, sounds good.
Yeah,
Unless you want to do a system design, but
that would be interesting. Can we do that?
sure, yeah, just leave it in then.
Okay, sounds good.
Cool. All right, talk to you later in a couple
Talk to you later.
hours.
Bye.
All right.
Yeah, bye.
Yo, this guy's gonna get the job with all this practice. All right, we got a 2 minute break. 2 minute break. Golden guy, thank you. Let's look at this. Raza, 1 second. We'll take a look at this 1 second. See you, man. Oh wait, we got somebody coming up. If we'll look at that resume if we have time after. Yo, what's up, man?
Hey,
How you
James.
doing?
How are you?
Pretty good, pretty good. Let's see. Have you done a interview before with me?
Yeah, I did one last week. I have an interview with Meta coming up, and I'm not prepared at all.
Is it a new grad? Like which
No, it's
position?
E5 role. Yeah, it's the expectations are too high.
What's E5? Is that medium
Uh,
level or that's senior?
yeah, the
Basically,
senior.
oh shit, yo, where is it based?
I don't know yet.
But
But
in a
I
US or
yeah, the US.
oh,
I'll
that's
have
gonna be a
to.
lot of money.
Yeah, that's the thing. Like, it's gonna be like 3, 4 times my salary. So I want to give
Ooh.
it a good shot.
Yeah, dude. Every time I'm doing an interview and there's a lot of money in the line where it's like literally you can get rich off the job, it's so nerve wracking.
Yeah, it's so nervous. Yeah. But
Okay.
I just feel like I'm getting overwhelmed with the preparation. Like, it's just so much stuff to cover.
Yeah.
But,
See.
so I don't know. I don't feel good in this mock interview. So I feel like I'm gonna bomb
Okay,
tonight.
I'm gonna start a video 1 second. Hey everyone, so today we have somebody preparing for a meta interview. They've solved 70 lead code questions and are based in Atlanta. How many years of experience do you have? Chat's asking.
I have 6.
6 years? Okay, wow.
Yeah,
So
6 in October.
he's actually interviewing for a senior role at Meta. So what's the process? Did they say?
Just the same. One systems design. 2 lead codes, one screening. Lead code, and then one behavior.
Are you sure it's not two lead code? Two? I thought senior's two system design.
No, for me, they just gave me one system design.
Oh, okay.
I I guess they can do a follow-up if they don't get enough feedback.
Did they say specifically that you're interviewing for senior?
Yeah, they can down level you if you don't do very well in system design, but you have to pass the coding rounds. That's
I
what I
see.
know.
Okay. What did I ask you last time?
You asked me from a grid problem from 0, 0 to the n, where there are walls, and you have to find a path.
Oh, okay.
And yeah, I was not able to do that.
Mm. So why do you think you're not prepared yet?
It's just so much different ideas you need
Mm.
to like know, and I'm just going through all those ideas, and also not. I haven't prepared for like lead code in a while, so
Yeah. Well, you've only done 70 questions, so you're still new to it.
yeah.
But
But yeah, I still have some time. Like, I have 2 weeks to prepare.
yeah, you only have 2 weeks.
Yeah, 2 weeks.
Yeah, it's tight, but I mean, if you study hard enough,
Yeah, it's possible.
yeah, anything's possible. 2 months, or sorry, in 2 weeks. But are you allowed to push it out maybe another 2 weeks, or no?
No, they said it looks really bad if you do that.
Oh,
The
really? That's what
recruiter
they
said
said.
it. Yeah, the recruiter said don't do that
Interesting.
unless
All right,
there's an emergency,
but like you couldn't schedule it before, or when they initially told you that you passed, so you already passed the phone screen.
Yeah, I passed the phone screen, and as like I said in the last live stream, like, it was borderline, and they were like, I don't know.
Yeah.
They said like usually they fail those candidates, but for some reason they passed me.
Okay. Cool. All right. So what have you been practicing in the last couple weeks, and what do you think you need help on?
I've been going all over, like the last, the most frequent questions from Meta. I've been trying to solve some of them, seeing the solution for some of them, but I'm not going in an organized way. So
Yeah.
that's probably why I feel overwhelmed. But I don't. I think any question is fine.
Did you study pattern by pattern, or are you just going question by question?
So I'm going question by question, which is probably why I'm feeling overwhelmed.
Yeah, honestly, I would learn the patterns by patterns. Learn stacks, then
Okay.
go and learn like DFS and do a bunch of DFS questions. So you have two
Yeah.
weeks. I would spend this week going pattern by pattern, and
Hmm.
then but I mean if it's only 2 weeks, I might just go question by question. But
Yeah.
usually I try to learn pattern by pattern, and then when it's closer to the interview, I start to
Hmm.
focus on questions specific to that company.
Right. I mean, I've done some interviews before, so but I just didn't realize I was so underprepared until I got to this Meta interview.
Yeah. Okay, cool. Let's hop on. Let's work through the first question. So in this first question, you're gonna want to return me the sum of two strings,
Hmm.
but there's decimals included.
Right. So yeah, this is one of the questions I did see. I did not solve it, but I did see some of the. Yeah, this is one of the questions I did that came up in my preparation. But I did not solve it.
Let's try
I
it.
Yeah.
Yeah. There's a lot
Okay.
of variations to this. It could be in a linked list. It could just be in a string. This one's in decimal. It's a
Right.
pretty popular question. So go ahead and try
Right.
it.
Okay. So as I said, yeah, I do have some idea, and I think the main difficulty in this problem is that uh, the behavior that we have after the decimal point is a little bit different from before the decimal point. Like the integer, you can add 2, 3 to 1 to, in this case, it's just 0. Uh, you can add that and just get 2, 3 to 1. But after the decimal point, you need to consider the number of decimals. So in this case, we have 3433. We cannot add it like this 001 and 3433. So we need to make sure the number of digits after decimals are equal. So that's one thing. I'm going to write that digits. Let's say after decimal or fraction. I don't know. Um, Fraction digits are equal. Okay, that's the one thing we have to be careful about. The other part is, okay, 2, 3, 2, 1. And then obviously we have to be remember the carry, like how to handle the carry. And then also we are given it as a string. So we need to do some kind of string too. Number transformation. Okay. And then the fourth part is also something I remember. So I'm not coming up with like on the fly. Is that let's say we have these numbers 2, 3, 2, 1, and then we have, let's say, another number. Oh no, 1, 2, 3. I'm going to change it. The way to do addition in strings, it's better to like convert to reverse the number completely. So we do 1, 2, 3, 2, and then we have the second number as 3, 2, 1, and we do the addition over here. Sorry, 4, and this will help us to make sure the carry in the numbers are handled correctly. So yeah, it's just doing the regular addition that we do, but we can do it from the left side instead of the right side. So this will be 4, 4. I'll just change it. Let's do this 7. Let's do this 5. So this will be 4. And then we'll add 7 plus 5. That's 12. And then the fifth point is I need to make sure that if it's it's probably in the same point. I'll just if it's greater than 10, take the remainder, and that part is also important. Okay. And yeah, I think if I keep in mind all these things, I should be able to write a solution for sum of two strings with decimal numbers.
So what's the approach? Figure out the number of fraction, or make sure that.
Yeah. Okay. Yeah.
Oh yeah.
So,
Could you just walk me through overall? Could you just spill some
yeah.
ideas?
So one of the first steps that we should do is find where the decimal point is for both of them. So if there's a string like this, what I'll do is that split it over decimal points, and I'll get this 2321, and I'll get 001
Sure.
as a string, and then the other one is 0.34333, and we'll get 0 as one of them, and we'll split over the 34333. We need to separate out the integers and the fraction because they have different behavior, like slightly different properties. Like I can add 0 to 2321, and it will be fine, but I cannot just add it. I cannot add until I make sure the 0 it's like until I make sure that how do I say this properly?
Yeah.
I
think overall it makes sense. Just go ahead and implement now. So we can,
Okay.
If you finish, we'll move on to a different question.
Okay. That might not be that easy. Add two strings. Let's call it as strings. S1, S2, and let's do the first part, which is just split it over, comma, S2, split it over, comma, S1 with S2, actually, yeah, I should not call it S1, S2 list, comma, and then we also have this in the split function, we have this another variable. I didn't know that before, but it tells us how many decimal points to look at, and this should be dot.
What's this?
Not,
why are we doing adding the 1 here?
we want to look at the first decimal point, like just in case there's another decimal point.
There's only gonna be one decimal point.
Yeah.
It's well formatted.
Okay. Okay. So this gives us should give us two elements. So let's say S1, let's say integer, and then S1 fraction is going to be S1 list of 0 and a list of 1. I've not implemented the solution before. I did see the idea, but I have not implemented. So this is actually the first time I'm trying to implement it. Okay, and then the second thing I said is we need to make sure the number of fraction digits are equal. And how do we do that? So we need to pad. We have this thing called pad left or pad right. I don't know exactly in Python what's the function, but let's just do it on your own, like pad missing numbers. It's still a string. We have not changed it. But let's say fraction 1, fraction 2, and I'm going to find the length of F1, F2, and whichever one is greater. Do it fast. If F1 then is greater than F2, then there's a inbuilt function. I just forgot what it is. What I will do is I will add zeros at the end of F2 until the difference between these two. I think that should work. F2 plus 0 times the difference between F2 F1 len minus F2. So I'm just padding zeros at the end.
Sure.
And okay, I have no idea if this will work or not, but let's just hope it works. And we return both of these numbers. So now, can I test it?
Yeah, you can run the code.
Okay. So I'll just test with these examples: 0, 0, 1, and 3, 4, 3, 3. Oops. Should I just return? I don't know. Okay. So we cannot do this. What if I do it like that? Maybe this will work now. Print it out. So it did not. It made no difference. Okay, that's because I'm not assigning it back. Probably. Okay, so we did the padding correctly. Hopefully this will work in the other example also. So now I'm going to use these functions. I'm going to make S1 the fraction, S1 fraction, S2 fraction equal to the same. Just going to pass it. And let's print out. That's fine. We'll print out later. Okay, now hopefully this is padded correctly. Now I'm going to write the addition function, how to add these numbers. So I'm going to create a new function. It's going to add two numbers as string. So again, we're giving num1, num2, and they're both strings. And one thing we do is we reverse it completely. This helps us to do the addition from the left side. Okay. Okay, how do I do the addition? So as I said, we have 1, 7, 3, 2. Let's say we reverse it completely. I'm going to remove this. Then we're going to go digit by digit. As long as there's let's say a number in both sides, then we're going to convert it to integer and we're going to add it. So num1 I is equal to 0, num2 I, num2 j is equal to 0, while num1 I less than length of num1 and num2 I is less than length of num2. We're going to num2 I, okay, num2 j. Sorry, these weird names I'm choosing. Okay. Well, they're both left in the length. I'm just going to add number. I'm going to add num1 and then num1I. So that should be a string. That should be a character. And
Mm.
I think this will work. I'm not sure. Maybe I can probably just do the int part. I think this will give us the number, the integer itself.
You can convert just a single digit if you want
Okay,
using int.
I can use int function, yeah. But let's just test it out, just in case. I'm curious about this part. So I do this. Oops, no. I do this. Doesn't work. What if I do art? There's also an art function, right? Art of 9 is 57. Oh, I can do, okay, that's what I can do. I can do art 9 minus art of 0. So
No,
this should
I
give
mean
me
you can convert the digit to int if you want.
Okay, yeah, I did it.
Just a single, yeah.
Yeah,
You don't
sorry.
need to do the
I
art.
was just
Oh,
curious
okay.
if this works.
Yeah, that's interesting. But it feels like non. It feels other ones it might mess up. It makes sense though.
It's just the weird names I'm choosing. Okay.
Mm.
And then what do? We just add them. So let's create a result and keep it as a string. Just add those numbers, num2 plus num1. Add it and make it a string. And we can use the pattern, the string builder pattern. But yeah, let's do that. So we append the result, and then one of them will still be there. So we'll just add that one also.
What is this doing here? Reversing the.
Yeah, reversing the string completely so that we can look at the you can start from the 0 index instead of starting from the last index. And also we have to keep in mind the carry. So I totally forgot that part. Have to implement the carry somewhere. Yeah, just comment out this part. So the carry will start as 0. Okay, let's just pass.
For time, we probably have 5 minutes left on this question.
Okay, yeah. Okay, I'll just do this part. Carry equal to. Oops. Yeah, this question is so hard to implement so quickly. Result divided by 10 is the new result. Before we do that, let's just make it carry is equal to result modulo 10. I think that should work. And yeah, we'll just add this one more time. And string of num1. Rise num2. And obviously we also have to add these. My God. So big. Okay.
To append, we just take the string of the number.
Yep. Sorry,
I don't get
I
that.
should, yeah, I should use this. Wait, so this is the idea. What part you didn't get it? I thought like when like one of the number might be smaller, so we might need
Okay.
to make
Okay.
sure we add the other one also, and yeah, we might need to add the carry also
Okay,
inside this.
let's not worry about the carry yet.
Mhm.
Or yeah, yeah. Or sorry, let's not worry about the decimals. Let's just get it working for something like 99. And then yeah, I'll assume that it's gonna work with the decimal.
Okay. And then just return the result, and then we'll also we also need to make reverse this one also, but I don't know how to do that. How do we can we do this? I think this will work. I don't know. So we'll create a new copy. Okay, let's try it. Add two numbers. There's definitely some problem
Or could
here. I
you
don't.
could you walk me through this code line by
Right.
line?
So
Sorry.
if we have numbers like I had this example 17. Let's say num1 is 1732 and num2 is 351 and 351. This is num2. This is num1. And yeah, so what I do, I'll just completely reverse it. I'll make num1 equal to 2371, 2371, and num2 will become 153. Okay, and then I'll just have these indices 0 set to 0, and we're just looking at the length. I think this should be fine, so I'm not going to work everything. And we have the characters. Yeah, the first character is coming as 1 from num1 int is equal to 1, and then num2 int is equal to 2. Hopefully this is also correct. So these are integers, and we could add those, and we get a result, and result is equal to 3.
Sure.
Okay, and then carry, we're going to carry. So carry is started as 0, and we do 3 modulo 10. That's definitely wrong. So we need to do the opposite. We need to do this, divide this by 10. And this should be the lower bound, and this should be the yeah, I think this should work. So I'm going to do the result is going to change from 3, and if you do 3 modulo 10, it's still 3. You do 3 divided by 10, that should be equal to 0. I think 3 divided by 10. Yeah, it should do the lower bound, I think, in Python. That's what it does. And then we're going to append the result.
Well, what if result is like 18 here?
Yeah, if we get 18, if we do 9 plus 9, then when we do result is equal to result modulo 10. Oh, we're going to change result to 8, and then we're going to do 8 divided by 10. So how do we change this? I don't want to. Okay, it's just let's do answer. Maybe use some other name for this answer. I don't know, answer chart. Maybe still. I also have result name over here. There's a lot of bad names. Okay, so if the result is 18, let's say we do 18. Now I can do answer modulo 10, result modulo 10, which will give me the answer char as equal to 8. And then I can do result divided by 10. That's I think it's equal to 1, right? 18 modulo, right? That's equal to
18
1.
divided by 10.
Yeah, 18 divided by 10. It does the lower right? It does not do seal in Python. So the carry will be equal to 1, which is, I think, it's the right way. Yeah, so we'll append 8, and we'll use the carry next time we do the addition. So I should use it over here. Okay. Yeah, something like this.
Okay,
I don't have time to implement this completely.
try it on like 99. Run the
Uh,
example.
yeah, it does still not work. Okay. Can I just add? This part is like completely wrong. So, but let's try it.
Try to see how you could fix that if you need to. Like, what's wrong
Okay.
with this? Yeah, I don't think that'll work. Could you look at it and figure out from just
Mhm.
observing it?
So line 48, int attribute has no. Okay, why the hell am I using those same result? Int attribute has no. Append. I changed it. Oh, probably over here. I don't know. Okay, let's do it one more time. What should I should return a string, right? So let's, I don't know why let's just do this. Start join. Okay, add 2 numbers.
You could just write it. You could just run the code here.
Oh,
In the console.
okay. So 999 and then 999 gives me 998, which is not too bad. I'm just missing a 1 at the end. And that's because if the carry is there, so I know this part is wrong, so I'm just skip it. But if the carry is there, if carry is greater than 0, then we need to append carry at the end. All right. Oops. Yeah, so this is better. If I add 999 and 999, it gives me 1998, which is correct, I think. However, this will not work if the size is different.
Mm-hmm. So just give us 108. Go 198.
198, yeah. Do I? Okay. So this is what's happening is it's adding 90 to 99. I don't know why. Yeah, this is when one of the number finishes first. So this 9 is done processing. So we go to so num1 is still left. So I'm just adding it. I'm just adding the 9. But it's not working. Trying to think. Okay. 99. So we finish this line. We come here. We have carry is equal to 1. Result is equal to 8. Right? The result is equal to 8. And I just add the 9. Maybe I should add it using the carry. So yeah, this over here. I don't use the carry at all. Maybe if I use it, it might give the right result.
What's your rationale there? Like
Yeah.
why is it breaking if you don't use the carry?
So if I add, so let's assume like when we add the 9 and 9, that's 18.
Mm.
We still have 1 as carry. And now I'm just appending 9, but I'm not adding the carry, the 1 from the carry. And I still have to do some logic over here, and I still have to do this logic over here. That's that's the part that's missing actually. So I cannot just do this. I still have to do. I'm going to do it a little bit differently. I'm going to copy and paste this code, and I'm going to. And I don't have to do it in this, and I don't have to do. I have to do. This might be completely fine. Maybe this is all I need to do. Num int is equal to. So yeah, I'm going to do the same thing over here for the second one, but you have to make sure I change the names. Okay, so anything that's num1 should change it to num2.
Let's move on to the second question. I think it's good so
Mhm.
far.
Can I just try to run it?
Sure,
just this part. Yeah, 108 is the right result, right?
Nice. Yeah,
99 plus 9.
makes
Yeah.
sense. Okay, come down to the bottom part here. So the next question is, I want you to generate me all the valid parentheses. So if I put n equals to 3,
Mm-hmm.
you
Let's
need to
add
output all the
pairs.
different parentheses like this.
Okay. I have not seen this before. Okay, I'll just start with the most basic example. N is equal to 1. What do we have? We have just this. So, by the way, how many are these? 1, 2, 3, 4, 5. Maybe 6 or something. N is equal to 2. We have what do we have? We can definitely have this, and we can have another one over here. Then we can have this. And is there any other combination I'm missing?
No, n equals to 2 is that.
Okay. I'm just missing a parentheses maybe over here. Like no.
Oh, no. You only allowed
No.
2.
Okay. So one idea that comes to my mind is whenever we have an opening parentheses, we get the closing parentheses, like we need the closing parentheses. So I guess they're pairs, so we can be guaranteed that they're like if they're n is equal to 3, then there's 6. Then there must be straight 6 positions to fill. So it looks like a combinatorics question. So because they're pairs,
I'll give you a hint. It's not. I mean, maybe you could do it with combinatorics, but you could do this.
Yeah, I mean we have to generate the pairs anyway.
Yeah,
so
you have to generate the actual strings.
If I have to just give a number, then yeah, it might be combinatorics. But yeah, I'm just thinking like when we have like n, I think we have n times 2 slots. Whenever let's say n is equal to 3, we have n times 2 slots, and whenever we put like a opening parentheses in one slot, like we choose 3. Let's say n is equal to 6, we choose 3 pairs, 3 slots. And as long as they're correct, we like when we choose 3 opening parentheses, we only have 3 spots for the closing parentheses. So yeah, so we're going to use that. So yeah, I think I know what kind of solution like these kinds of problems require.
Mm.
Like we just have to generate all of the different combinations that are there.
Mm-hmm.
So um, yeah, yeah.
So what solution usually does that entail?
Yeah, I know. Yeah, yeah. This looks like a tree structure. So we only have to go to depth 6, right? The depth is 6. I don't know. It is backtracking, right? I don't know how to do
Yeah,
it.
you can solve it with a backtracking algorithm.
Yeah, because we have to generate all the different and show it. But the way I like to see backtracking is in the tree structure, like in the how do I get it inside the tree structure? So that once I see that, then it makes more sense how to solve it. Um, so as I said, there's 6 slots or n times 2 slots, and the height of the tree is probably just n times 2. And for every we have to the root node of the tree will likely be opening parentheses. I don't think we can start with a with a with a closing parentheses, and then we have 2 choices. We can have another opening parentheses over here, or we can have a closing parentheses, and then we can have another opening parentheses, or we can have a closing parentheses. I'm just doing for any sub to 3. And once we have that, then we are almost guaranteed that let's say the left subtree, opening parentheses, we're almost guaranteed that all the rest of them are closing parentheses. And over here, so yeah, using this logic, where for every time in the data structure, like in the DFS, we either open the parentheses or we close the parentheses until we reach the total number of parentheses. I think we can approach it like that.
Okay. So at the first level of DFS. So let's go into the drawing. Maybe it
Mm-hmm.
might help you.
Oh, there's a try
Mute
mode.
that. Yeah. There's a drawing mode. So we just start with the empty, right? And then you're saying we're gonna be doing a DFS, so there's a tree kind of structure. So
Yeah,
what?
we have every child, uh, we have 2 choices. We don't we
What's
can
the
either
choice here?
choose closing or we can choose opening.
Can,
Every node we have 2 choices.
can we just actually just choose closing here?
Oh, sorry, I don't see.
I'm a bit
Oh,
above you.
okay, now I see it.
Okay. So
So,
coming from empty, right? Can we
uh-huh.
actually just go closing right away?
No,
Why not?
that will be an error. We cannot have closing as the first root. I thought the root will be in opening parentheses.
Oh, the
Uh,
root. You just said at each we have an
yeah, that
option.
makes more sense. Yeah, that makes more sense. Root should
Okay.
be.
What about here? What's the
Yeah, so
options
we
here?
need to. Yeah, now we can choose a closing parentheses.
Could try enumerating from here.
Okay, I don't know how to. Okay, closing. Okay,
Okay, from there you can go
so
open.
another opening parentheses, and we can have another opening. Okay, and then over here we can have closing. Can we have another closing? No, because we are. Okay, yeah, that is a good point. We can only have a opening parentheses now. We cannot have a closing now because it's the number of closing cannot be greater than number of opening at some point. Yeah. So over here, once we have opening, we still have 2 choices.
Okay. So when you're
My
at a
drawing is
node,
really bad.
when you're at a node, how are you gonna know
Yeah.
if you're allowed to open or close there now?
We're gonna keep a count. Definitely, we need a count of how many we we've opened so far and how many we have closed so far. So at this node, we'll have the count of how many we have opened and how many we have closed. And if the closing is greater than opening, then we cannot close it, or is equal. Yeah, something like that. Every in the tree, every node has a count, or maybe it just needs to. Yeah, it probably needs the count of all the opening and closing parentheses
Okay.
so far.
So when
So the root node.
we're going down to the, like, what information are we passing into this node? The number of openings and closings.
Yes, both of that. So start at 0, 0, and then let's say we go to the left to opening, and then since we say opening is 1, closing is 0. When we go down, we pass the information. Opening is 2 now, and closing is 0. Maybe like that. The DFS will be like that.
Okay. You think you'd be able to implement it or no? On the spot or no?
I can give it a try. It's
Yeah,
probably
spend a
won't
couple
work.
of minutes because we're almost at time anyways.
Yeah. Okay. We don't need to do a clean note, right, class?
Our
What
function
should be
is just called like generate.
generate
We're
parentheses?
gonna be
How
given
do I
an
get
n.
out of try? Okay.
We're just gonna
Generate
be given an n.
parentheses. Oh, okay. Just one number. And yeah, the opening create an opening parentheses, something like that, is equal to 0. Closing parentheses equal to 0. Let's see if I can implement it. We have to do a DFS. Oh, do we do a DFS? Yeah, we do a DFS, yeah. And what do we have? You have a node. It's a node car. And we have a number of opening and number of closing. Okay. And do we need to go in any particular order? I think we should go to left first. First, if like there should be a closing condition. There should be a what do you call it? The condition where everything like
Base case.
like a terminating condition,
Yeah.
which is if the number of opening parentheses or closing parentheses to either of them is equal to, or both of them are equal to.
Well, how are we maintaining the choices we already made before?
I'm using this like I'm passing the number, opening parentheses and closing parentheses, and once they are
Yeah. Well, I mean the final result, right? We need to actually build the string and then add it to some result to return. How are we doing that?
oh, okay. So yeah, we have a result array over here. And once and oh no, because we need the previous levels also. So trying to think, do we need a current, some kind of current, like where we are. We could have a current over here, which could basically, and then I think in the backtracking we could have this backtracking current, which where we add it and then we remove it. So I'll just use this condition: if opening parentheses plus closing parentheses is equal to let's say 2 times n, and then let's assume we have a current. I use the same name again. We have a current which has all the parentheses so far. What we'll do is we'll just append it to the result, something like that. And then, but even before that, we have to make sure if the node is null. I don't know if this should be a null condition. Else we have a few more conditions. If opening parentheses is equal to, let's say, n, we have all the opening parentheses. We need to add it. We need to do a DFS again, but not really, because we kind of know. Man, I'm just I'm not making any sense now. I'm just making. I don't think this makes sense. I'm saying that the right note is always the closing parentheses. I don't know if that makes any sense. If it does, then this might work. But man. One thing we also have to make sure is the closing parentheses are not greater than the opening parentheses. So
Exactly.
if it is, then we cannot add it to the result.
Okay. How are we handling the result? Maybe let's spend the last little bit there. Like, how do we handle the result?
The result should be a list of lists.
A list of lists?
Yeah, like like this. Oh, this is a string. Okay. Um, yeah, I'm not sure. I don't even know what the DFS, like, how should I even do what I'm recursing on? I'm not so sure at this point.
What's cur here? Like,
It's like
when are you actually updating cur?
so the idea was like we built the path on this curve, uh, but that and then we remove the path, like we do like the way we do in backtracking. I haven't practiced backtracking much, but
Yeah.
the idea was like we have a backtracking function, and whatever loop there is, we do DFS. We either consider okay, this is the idea. Like we either consider the opening, we append it, we do a DFS on that, and then we remove it.
Yeah.
Something like that. And we do a DFS again on that. Something like that. This was the idea, but
Yeah.
and once
Cool.
we do it, then we flush it like completely. We make it like
Yeah.
maybe
Makes sense.
it's will work. I don't know.
Cool. All right. We're pretty much out of time. So,
Mm-hmm.
how do you think you did? How was that?
Better than I expected, actually. But also because I'm familiar with, I saw, I'm a little bit familiar with this question. Like I did come up in my practice today. I saw a solution for this somewhere in like one YouTube video. This one I'm not so familiar with. So yeah, I struggled with this one. I need to practice on backtracking a lot more.
Yeah, you should just understand backtracking. I think you were able to come up with something close, but just implementing it, you're having a lot of
Yeah.
trouble. So just learn
Mm-hmm.
backtracking. It's kind of boilerplate. Like once you get it
Okay.
once, it's boilerplate. Handle the base case, then handle the backtracking case, which is what you mentioned is try something, recurse, and then pop it out of the path.
Right. Yeah, I got some idea. And again, I did backtracking in the previous interviews, but not for this one so far. Yeah, those questions have not come.
I think also, yeah, you just need some practice because you were able to get the first one, but it just took too long. So
Oh, okay.
especially at Meta, it's all about speed. They're gonna ask you two
Mm,
questions in a span of 45 minutes. So the
yeah.
questions probably won't be that difficult, but they won't be hard, but they're gonna require you to move fast. So just make sure you're timing yourself when you're doing it, and just be
Okay.
able to move fast and write fast.
Okay, yeah, thanks for the
Yeah.
advice. I
I
keep
think
this in mind.
your dry running was good though because you were able to catch an edge case there. But yeah, just work on speed there.
Mm-hmm.
Like clarify some
It is
questions and then come up with like one or solution, and once they agree on it, just start implementing it. I don't think
right.
they'll make you
Yeah,
even run the code actually. They'll make you more dry run it, so you just make sure that you know the or like that you get something like out.
right. Yeah, makes sense. Yeah, this question was just like a little bit long to implement. Yeah. But yeah, thanks for that. Yeah, thanks for the mock
Yeah.
interviews and like
Yeah.
all the advice. Like, it's super useful for everyone, I think.
No problem. But yeah, I think no, you did. I think chat saying that if you could push it back also by like a week or two, you should. And I thought
Okay,
about
I'll
it a
try it.
bit. I thought about it a bit too. I mean, it's
Mhm.
risky. You can push it back, and then you might not get it, or push it back and it looks bad, or if you go too early, and you don't do good, you might not get an opportunity for a long time. So I mean,
Right.
there's two. It's a
I'm
balance.
planning to take some days off from work. So I'll practice a lot more on those days and
Yeah,
hopefully build up skill. Just a few days. But
yeah.
yeah, thanks a lot. Thank you.
Well, I'll just say one more thing. It's just yeah. When you get closer to the interview, just 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 straight up read the solutions.
Okay.
Just memorize them.
Yeah, unfortunately, I did not implement this question. But I saw the solution, so
Oh, okay.
I knew what the stumbling blocks were for this
Yeah.
one. So yeah.
Cause yeah,
I-
they like to ask like the top 100 questions type thing, like if, on the meta
Mm,
tag. So if you know all the
yeah.
solutions, you should be good. You don't want to get into that interview and not know a solution to a question,
Yeah.
cause there's not
Yeah,
enough
honestly,
time to figure it out.
in my screening round, like both of those questions I was not familiar with, and they were both from top 100. Like they
Mm,
were. So yeah, that's why I'm like focusing a lot more on
yeah.
these top 100 questions. But yeah, thanks a lot.
Cool. Good luck, man. See ya.
Yeah, thank you.
Bye.
Bye.
Okay, we got one more person from Dallas. Only 60 leak code questions solved. Is that a good strategy? The best strategy is actually learning how to solve the questions. But if the interview's a week away, just straight memorize the solutions. Ideally, you actually study for it and stuff, though. Be right back. Liam Hayes in the building. Alright, who do we got next? Gonna do some more vibe coding tonight. Liam, what's good? Yo, what's up?
Hello, I'm audible.
How you doing?
I'm good. How are you?
Pretty good, pretty good. Your mic is a little low. Would you be able to like bring it closer? Or your mic? It's all
Uh,
good if your mic is not good.
Let me just try something.
Yeah, try something. Try to fix up the mic if you can.
Better?
Pardon? Say it again.
Is this better?
Yeah, it's better. It's better. Cool. So
If I learn nervous.
yeah, cool. So today we have somebody from Dallas, graduate from UTD. What's UTD?
University of Texas at Dallas.
Nice. Cool. Done 60 leak code questions. So you're just getting started, beginner.
Yeah,
Nice.
unfortunately, yes.
How is it for you? Just ramping up. How has it been?
It was good. Like, still, like, I'm trying to find a job. The applications are on, but yeah, I just need some more lead code practice.
Yeah. Are you complete beginner, or you're able to solve mediums now?
I have started with that neat code 150 list,
Yep.
and I have finished arrays, strings, and I guess some of heap as well.
Oh, you've done heap. Okay.
Uh,
All right. Let me think. So what interviews do you have coming up?
None as of now. I'm just practicing and trying to learn.
Did you graduate this year?
Yeah, May 25.
Oh, you're not graduated yet, but you will graduate in.
No, I graduated May this year, May
Oh, okay.
2025.
Okay, I see. That makes sense. Cool.
Yeah.
All right. So, what do you think I can't ask you? No DP.
I mean, I'm not sure about EP. I have not practiced those yet, but I have done some graph as well, DFS, BFS, but yeah.
Okay. All right. Let me look for a good question. Give me a sec.
Yeah.
Give me a sec. Okay. So this is gonna be. So there's gonna be multiple parts to this. I just want to see how you think through this question.
Okay.
But I want you to build me a file system.
Okay.
So we can call this file system. We're gonna create a file system class, and we just need to organize the different files into a folder structure. We need to be able to add files for now, and then be able to tell me all of the files under a directory.
Okay.
Recursively. So
Okay.
yeah, how would you think about working through a question like this?
Maybe like in a tree data structure we can use here. So like is the file just a name or does it have any other Uh,
So
I don't know.
implement me something like this: add file,
Okay.
and then print directory. So when they call add file, they're gonna be given. They're gonna where you can add a file like a regular file path A B C, and then hello.txt. And you could assume this just means that we want to insert an A, B, C, and then hello.txt. So we could assume that the the files are in a good structure. I mean the URLs we pass in are in proper structure.
So, like the file name here is hello.txt and A, B, C would be the folders, right?
Yeah. So
And
it's nested in A B C.
okay, and like I'm assuming that A, B, and C, like all these folders are there. The
If they're not there, you need to create them.
okay, okay, okay. So maybe uh, I can create a folder object or like a folder class with name and children. Children name would be a string and children would be, I guess, a list. And then we can create a file system class and it would have add file uh, and in the add file I would be given this, right?
Yeah. We can call it
Like
any
something like
number of
this.
times. Yep.
Okay, something like this. Okay, so maybe file path and print something like this, I think. So let me just create a class for folder first.
Okay. Wait, so let's talk about the different functions quick. What happens when you add?
So maybe in add file, first I need to get all these path and the file name. So maybe I can split using this. Then I'll start with the first folder. I'll check. Oh, I need a map. Something like this. Check if it's there or no, not. So first I'll check folder is equal to this, and maybe in folder. First I'll check for the first folder is A. Maybe I can recursively check whether A is in the map. If A is in the map, I have to check for the children of A is B in that, and like recursively there. And then when I reach C, I can put this file over there. the children of C. And I'll also add it to the map. Something like that. Or maybe I can just maybe I can use a graph structure over here. Uh, I think. I'm sorry, I'm just blanking a bit right now.
Wait, what are you stuck on?
Uh, I think I can use a graph structure over here. And yeah, like something like this. Like A has B in it, and then B would have C in it, uh, and C would have uh, hello dot text. Like this would be a list, I guess.
I like your tree approach before,
Okay.
but I'm just asking how are you actually gonna build the tree? So pretend we call add files with this. How are we gonna build the tree?
Uh, so maybe we can, like after splitting it and getting all these files, I can start with, uh, where do I search it though? Where do I start A with? I need, or, oh, I can maybe, so is there a folder, like maybe, can I assume that there would be a root folder and in the root then there is this structure? Maybe something like that. So I can start searching with root then
Sorry, what did
go
you
up.
say?
So like I'm thinking that if I start with the root like directory, then in that maybe I can recursively search for A. Then when I find A, then I can just keep on adding in to the children. Then the children of B I can add C, and children of C I can add hello.
Yeah. It makes sense. Try to go implement it. I think you have a general approach, but you just need to work out the details when you go to implement it. Usually I don't recommend it, but we,
Okay.
yeah, I think we'll make more progress if you just start implementing.
Right.
all you wanted.
And I got there, and I need to add file.
Chat, what should I eat for dinner? I got Trader Joe's. What are y'all eating for dinner?
Maybe I can use a set over here, so it's easy to look up. If
Deep dish slaps for sure. They have a real good deep dish spot in SF called what's this place called? Golden Boy Pizza.
cannot access member for type folder.
Oh, you just spelled children wrong.
Oh, okay.
Okay. Cyclops, what's up? Yo, isn't it late for you? It's like 1 a.m.? You sleep early, huh? Or you sleep late, huh? Oh, I didn't realize you're only 1 hour ahead.
So I need the file object as well. to traverse, I guess. So
Jan, go back to
set
sleep.
would not work here. I think I would need a hash set over here instead of this.
Okay.
And so the key would be like the name of the folder and the value would be the object. And this add the file over there. Like let's say I pass this and I'll split it into A, comma B, comma C, comma hello. Okay, and like everything is empty and I just have root here and so let's say the current root is root and then so for first for A like is A in current root children, current root is the root and root children is empty right now, so it's not in there, so I'll just create a object. So the file would be folder object with A and for current root children, that is root children, and with the key A I would have the object, and then I would change the current root to this object, so that is A, and I'll again for second and B it will go again in this, the current root is A's children are empty, and again I'll store the object of B, and then I'll go to C, again same, and then again and hello. So what if I add something that is already there, right? So maybe what if I add something like A and then B and then Z. So till A be till the same and C it will add new. I think this would work for add file.
Okay, add file. You split. We put in the root. If the folder is not in the current children, we create it. Okay. So now create me print directory. As in, I just want you, if I say print me ABC, I want to print everything under ABC.
So like just one folder's name would be given, right? So maybe for example, just A is given and I have to recursively print everything in A, then everything in A's children and so on, right?
By the way, we need to be able to support this. Like multiple files under the same directory. So I need to be able to, let's say, add these files, and then afterwards, be able to print directory like this, A, B, C, and it needs to output me hello text, Yo, and James.
Okay.
In a list.
Okay.
Does that make sense?
Yeah. So everything in the in this directory.
Exactly.
Right. Right. Let me just check. Or so maybe I need to first reach this directory and then I can just print every children of that node. Right. So maybe
Well, I need to be able to pretend there's B and there's right. We inserted that,
okay.
and then I put A B. What should happen? What should I get?
I'm assuming random text.
And
Also, do I need to print all these as well? Like because C is in B, right? So I need to print these
yeah,
all as
yeah.
well. Okay.
Print directory should tell me. Yeah, it. I think I mentioned it earlier, but we need to tell me all the files under directory recursively. So
Okay.
if B is at
Okay.
the top level, we still need to recursively print out everything under it. So under it could be files, but then it could also be more folders that we need to search through.
Okay. Mm, so first I start with root, then I go till I find this. Like what if there is no such path? What should I print then? This empty string?
Empty list.
Okay. Empty list. Okay. Mm,
Well, I can create.
no. No. So I just need to find because till I find the first one, right?
I think I have a good sense of how you are with trees. So let's move on to the second question.
Okay.
So we're gonna be given a string. We need to find me the
Okay.
length of the longest substring where the characters alternate between two different letters.
Oh, okay. So, like, can the string be empty?
Yeah.
Hello,
Yeah.
am I audible?
Oh, can you hear me? Yeah.
Uh, I said, can the string be empty or no?
Yes. It could be empty.
Okay. Okay, so the substring should be strictly alternating. So maybe I can create a map for like what two characters are in the current substring while traversing to the string and keep on checking like it would be a two-way map. So for example, A would have B and B would have A. Like those are the two current let's say those are the two current characters that we are checking, and so like while this is like while the next character is the value of that key, keep on going, and maybe that's but what if we find something else? So then we have to update our map again and traverse to the whole through the whole string and keep on updating max after we update the map, I think. Is it the right approach or
So, wait, what's the map for again?
so like to check what two strings are like what two characters are in the current substring.
What two characters? And then what?
So like first I start with A and then B, like I create a map for the first two characters of the string. Then the next two should be the value of no, that would not work.
It needs to alternate between two characters: A B A B A B, A Z A Z A Z, C D C D C D.
Right.
But just any two. We just need to find the longest one that alternates like that.
Mm-hmm. I think maybe we can check whether like next to next character is same as the current character, or mm,
Can you be more specific on your approach there? What do you mean by checking just the next?
uh, I'm sorry, I'm not sure how to do this.
Okay, let's try to simplify this.
Mm,
Maybe just write a function that just returns me the longest of one character.
okay, okay. So maybe in this we can like traverse through the string, and like I'll store the first like, current character as the like first of that substring. For example, let's say over here A, and then while the character like this string of I is equal to current character. I keep on incrementing the I, and when it breaks, I'll update the like result as max of result, and uh, I don't know. I also have to store this variable defined, right? So maybe L would be the uh, index of current character, and I would say just say R here, and R would be this here R minus L, and current character would be. I guess I'll just do something like this. L and R is equal to 0, and then I'll store the current character as string
Why
of
do we need to
L,
store the current character?
to check uh, this, or maybe I can just keep on updating while string of R is equal to string of R plus 1. I think then I don't need to store the current character. Then I can just do this, and then I'll just update L to R plus 1, and R is equal to L plus 1, I think. So basically, I'll just keep on incrementing the right pointer till it is same character as
You
its
awesome guy, long
previous one,
time.
and after that is broken. So for example, after it's broken over here,
Like,
in
what's the
B, then
L?
I'll
What do we need the L and R for? What's the L?
to keep a track of the current window or the current substring length of substring.
Okay. So let's work through this example right here.
Okay.
And then show me how the left and right is going to behave.
Okay. So L would be here. Then R, like while string of R is equal to like it's same as its next character, I'll keep on incrementing R. So it will be there here, and it will break over here. It will break over here. then I can store the result as uh, r minus l plus 1.
Okay. I think go ahead and implement.
Okay. Mm, let's try run this first once. So L is 0 and R is 0 over here. Okay, then while R plus 1 is less than len and s of R is equal to, so R will increment here. It will stop over here because R is A and R plus 1 is B. So I'll update max as this, like R is 1, is 0. 1 minus 0 plus 1 is 2. This is the length. Then I'll update L over here, and this would be R. And again, while R plus 1, so R will increment till here. Stop here.
Okay. Try it out. Or dry run it.
Okay,
Yeah, dry run it.
yeah.
Let's see.
So this is 2 now. Then so L would be 0, 1, 2.
it's working. Okay. Do you think you could extend it to the 2 characters that we were talking about?
Mm, for that, I need to check for every increment, is it alternating or not? So how do I check that? Mm. So if I check like this, but I'll just increment this by 1. No, I don't think this will. Let's just dry run it once. This is R. Okay. So while R is R plus 2, then I'll increment by 1. And again, I'll check this. Is it same as this? Then I'll check increment once. Then this. Then I'll increment once.
Search. Usually there's like
once.
in all the tools you could just click drawing and there's gonna be a drawing tool. Like, and if you're working with arrays, you could just explain it in the same way he's doing it here, like that.
And I'll stop over here. R plus 2, it's not there. And I can R minus L plus 2. It should be 2 over here now. What about this one? L here. R also here. I'll go until 1, 2.
Okay. I think we're pretty much at time.
Okay.
So, yeah, I think you got the first version. So how do you think you did? How was that for you?
I think I need some more practice. I was scrambling a lot, I think.
Yeah. Honestly, you're able to, like, you just had trouble coding, but you're able to find the solution. A lot of candidates have trouble finding the solution. But you were able to find the solution, but it was just having trouble coding it. So for the first question, you were able to find a proper solution, but it just took a while to code it.
Okay.
Like, we went up to 30 minutes and then just ran out of time.
Okay.
Second question, you were able to find the solution for the simpler case. But then what you could, I think, but you described the proper solution at the start. For this one, you don't really even need like a left and right pointer. You just need to compare you just need to create some sort of count.
Okay.
Right? Like, you just have one pointer and you start the count at 1. You have a max.
Okay.
And then if A is the same as the other one, you just increase the count.
Right.
As the one behind it, you just look backwards to increase 3. And then when you go to B, you reset this to 1, but each time you're maintaining the max, right?
Right, yeah.
I think for the 2, you just need to look at, it just makes it easier for when you're working with 2s. Like, you'll be able to extend it. if you're working with two. I think just count one here. One. And then move it over by two. By two, right?
Oh, okay.
Is it the same? Is this one the same as the one over here? Is this one the same as the one over here? If it's
Okay.
not, if it's not, if it is, then you can move it forward. If it's not, then I think you could probably work one backwards kind of thing. Like it's a slight variation, but I think you're able to solve this one. But you did use the sliding window, which is fine because you're able to implement it and it worked. But there's a more subtle, easy solution that I mentioned there. But overall, you did
Right.
good on the second question. The first question, you also found out the answer. Your code looked good, but it just took forever to implement it. So just work
Right.
on, try implementing that by yourself. Like watch the video again to see what the question
Okay.
is, and just more repetition. I think you have solid problem solving skills. Like you weren't completely stuck. You just need to just continue practicing.
Okay. Yeah.
But yeah, yeah, that's pretty much it. Is there
Yeah.
anything that you
Thank you.
noticed when you were doing the interview that you thought that you think you need to improve on, or you're coming to a realization?
Yeah. So what I observed right now is that like I do talk a bit, but I mostly code very silently, and that
Yeah,
like I should think out loud more, I guess.
yeah, you definitely do are pretty quiet, but it's not terrible though. It's not completely terrible because I knew what you were gonna, because you talked about your approach and then you went and did it and you're kind of silent during the approach. But yeah, you should talk about your approach. You don't have to be constantly talking the whole time, but
Okay.
talk about when you need to make certain decisions. So
Right.
when certain parts are important to the algorithm you're writing, you should make sure to mention it. Be like, oh,
Okay.
I'm writing this while loop and I'm gonna increase it. But you don't need to just narrate the whole thing.
Right.
Yeah. So it all really depends on you. But yeah, more communication is usually not bad.
Mm-hmm.
All right. Good luck.
All right. Thank you. Thank you so
No
much.
problem. No problem.
Yeah.
All right. Yo, chat. That was the last one. We're gonna take a break next weekend, but then we're gonna do a I think maybe next weekend we are, but we're gonna have a ton of coding interviews because this is the last stream in August, but then September, October, November, December is really when people are gonna be grinding. So we just need to. It's gonna be a grind. It's gonna be a grind. I hope everyone like that guy lands his Google. Yeah, yo, we're gonna do a ton. I hope that guy lands his Google. We have Meta people interviewing at Meta, Waymo, Microsoft. There's so many different people interviewing everywhere. Paul just about to get his Meta offer on Monday. It's gonna be crazy. But yeah, Cyclops about to get his MongoDB. There's a lot. Yeah, I'll do a long ass stream. Maybe I'm gonna do a stream where I try to do all the blind 75 questions in one go, or the Peralta 75 questions in one go, or something. Or I'll do a stream where, I don't know. We'll come up with something. We'll come up with something, like a long ass one. No, last year I literally did a 24-hour stream. I tried to do blind 75 all in one go, around Christmas time. Yeah, we're gonna do a full interview process on Alpha or somebody. But last year I tried to do blind 75 in one go, and after 14 hours, I had to sleep. So I left the stream going while I was sleeping, and then when I woke up, I finished the rest of the questions. It was crazy grind, and I was completely rusty at leak code, so I sucked. So it took me forever to solve some of the questions. But then the stream was so long that YouTube ditched it. Like YouTube couldn't hold it. Now we'll come up with some ideas. Oh, another idea that I'm doing is I'm gonna actually try to do some lead code classes on stream. So maybe put a bunch of kids in a room and try to teach them array, like go through the different patterns or topics or something. I don't know. Yeah, Alpha. Let's do it. You do it in Java and I do it in Python. That'd be funny. Yeah, I'll do more system design interviews too. Dude, there's a bunch of content. Maybe I'll do. Yeah, we're gonna Alpha. We're definitely gonna do an on-site for you. We're gonna have a few people. John CFA will put you through a behavioral, and then like my other friends will put you through a coding. You'll go through a full loop. Yeah, we'll put CFA will put him through a behavioral. That shit would be so funny, but now, yeah, do you know what, Rag? No, he's gonna be asking you questions. Yeah, Alpha, hurry up, get some rest, get prepared, and we're gonna run a full loop on you. That would actually be hilarious. We'll just keep the stream running each time. We'll give you like 15-minute breaks between each interview kind of thing. And at the end, we're gonna do a hiring committee to see if you get the job. Then we'll make John CFA do we're gonna have behavioral interviews, everything. But I don't know about behavioral. We'll see. No, we'll put you through We'll put you through 2 coding, 1 system design, like a mock behavioral. I don't even know, something like that. That'd actually be hilarious. Yeah, and you can stream the whole thing too. Yeah, behavioral might be hard without doxing. But I'll tell Alpha to prepare. Just prepare some. I'll give him some questions. I'll pre-prepare the questions just so he doesn't dox himself. But then we can go through how you would actually do well in a behavioral. Dude, chat what they gonna dox? I mean, yeah, Alpha already doxed himself. But yeah, I think I'm trying to find a way that we can do some classes. Like, y'all know any platforms where we can put on like a bunch of students who are trying to learn DSA and we can teach them live? Where it'd be sort of two-way communication. Maybe they can raise their hand. Maybe I'll like have a Zoom. I don't even know, and then they can kind of raise their hand. Yeah, maybe I'll do a Zoom. Yo, that'd be crazy. The resume maker app, you should build that. I have one for generating cover letter. It's so funny, yeah. John, this is the ranking of words he says the most. He says CFA the most, then he talks about China second most, then RAG third most. Yo, that'd be crazy. Yeah, in the Discord, we'll hire some people. Alright, chat, I'm gonna get back to vibe coding. I'm pretty much, right now I'm trying to build a bot that's gonna download the transcripts from all of my videos. And then I'm gonna actually build like a RAG so that you can ask questions and then it'll find videos related to the question you asked. That's what I'm working on right now. Yeah, Cyclops, go connect with me. I didn't know you haven't connected with me already. Running Bedrock? Nah, dude, ChatGPT, GPT. Oh, I'm gonna try Codex too. Codex. Where is this? Dude, there's so much. I need to play around with a lot of this stuff. Yo, I'll check right after. But there's a rag here. Yo, Paul, look. I don't need to run Bedrock. I'll just use the retrieval API. John did this. John was able to do this. It was so easy. Why would I use... What's the benefit of using Bedrock? It's more customizable or what? Dude, Alpha is cracked, man. Maybe what I'm gonna do soon is start grinding towards, instead of doing mock interviews, well, I'll mix in mock interviews, but I'll do streams where I'm grinding towards 1,000 leak code questions. Because I need to get on Alpha's level. I'm only at 600 and something. Yo, chat, but I added a bunch of new stuff to my website. Let me see. I added like the number, so now I pull in all my data. So before I used to hit the YouTube API to pull in all the data, like the videos and stuff. But now I pretty much, or I have a cron job that pulls the YouTube data and then puts it in my own database because I was getting rate limited like crazy by the YouTube API. So now I'm not getting rate limited at all in my own database. And then now I have the data inside of my database. I can create aggregations. So yo, I have 438 hours of content already in the last 9 months. I was tweaking out. So I also added like role-based access control. Let's see. I'll show you some of the new stuff that I added to it. Charlie, I used Next.js. So I added role-based access control. So I'll show you one thing. Dude, I have a video on it. But essentially, we have different roles now. So this one that I'm at is an editor. So I can have editors come in and make me thumbnails now. So I actually been having someone make thumbnails for me. So when they log into the website, they can like create thumbnails for me. But if you try to access this thumbnails page and you're not logged in or you're not an editor role, you'll get rejected. So that's called role-based access control. Let's see. Where's that code? That code is pretty much like when we do the auth here. This is my auth. I'm not scared to show my code because this thing is secure. So wait, where is it? Dude, I'm not scared to show my code because all my stuff is secure. And I would prompt GPT also. So I every time I, like from time to time, I would ask the agent, I'll be like, is there any leaks in my code? And it would tell me if there's anything. But you can see this is my role-based access control. So pretty much when they perform a auth, we get their role from the database. So yo JN, see ya man. When we do a auth, we grab their role from their user base. So we look up their email based on their JWT token. And then we grab their role and we store that in the JWT. And then pretty much in the middleware, Pirate Software? Isn't that guy getting canceled right now? Or no, that was somebody else. Somebody else, Coding Jesus, dropped some videos on him, and the videos are so hilarious. But pretty much, this is the role-based access control. So we figure out what your role is, and depending on the URLs that match, we do a regex. If they try, for example, if they try to hit thumbnails or thumbnail job, and they're not an editor, we pretty much redirect them back. If they try to look at my analytics and they're not an admin, then we redirect them back. So yeah, that's kind of, we have the role-based access control there. My cron job is here. So I have this cron job that runs every day. It collects my latest videos, collects all the video IDs, and inserts the video IDs into my database. So you can see each video, I get the title, the description, the duration, the date uploaded and stuff. So now when it's all in my database, I'd never have to hit YouTube APIs again. And then sort of, where to do that? And then I just have to define the cron job schedule in here. And then Vercel deploys the cron jobs and we'll run them every day at 7 a.m. I'm hosting everything in Vercel. Yeah, my cron job runs in the backend. It runs in Vercel. And then Vercel also deploys all my APIs here. Show the .env. So yeah, all this data right now is not being pulled by YouTube. It's being pulled by my in my database. And I have pagination here. Infinite scroll alpha. This. Well, infinite based on my how many videos I have. If you actually click this, it goes into the right videos too. But I'm adding a lot of automations in the background. So I'm trying to automate a lot of different things, especially generating all my thumbnails, generating all my transcripts, generating all my timestamps. No, I don't use any of that alpha. I just basically render it into the DOM. So I have this client. So I have this videos list. So it just has a list of videos, and it just keeps adding more videos here. It just keeps, when we do load more videos, it adds more videos, and then we just like map over the videos here. Honestly, I vibe coded 95% of this. What calls load more videos? I think when you get to the end, no idea, man. That's a good question for the AI. So that's the AI. But check, I can create thumbnails here. I can go from here and actually like add thumbnails, submit the thumbnails, and it puts it in a S3 bucket for me. And then I could just review it. I can click here and download it. So I can see it here. And then when I'm done, I can say complete. But I'm also gonna add a chat feature so I can chat with the person building the thumbnails and give feedback from there. With solution videos. Yeah, I'm gonna build solution videos for all of my videos too. So when you go in Peralta 75, you can run it from there. I don't know if I want to make a platform where they can run and submit. I think I'd rather have them just run it on LeetCode. Yeah, do that, Alpha. I actually have like a cover letter generator. I forgot the name of my domain. I had a cover letter generator. Where's this? Run ads. Wait, I'm looking for my cover letter generator. Yeah, if I collab with girls on this channel, I'll definitely be way more famous. But I don't know if I want to do that. Should I do that? I have a girlfriend though. I'll get in trouble. Let's see. Get them on the stream. They're always scared. People are scared to embarrass themselves. Dude, I'm looking for my cover letter generator domain. I bought one. I had a cover letter generator. Okay, let me check my Amazon. Because that thing's just running. Whatever. Okay, I'm going to get back to vibe coding. I'll see y'all soon. Then I have work tomorrow. Yo, good night, good night.
This is not my main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, 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 LeetCode, beast mode. This is not my main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, 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 LeetCode, beast mode.